Hey, what's up, everybody? Welcome to the Reliable HVACR live stream and podcast. I already see a lot of familiar faces in the chat. Eddie, Stevo, Brian, Just Work. I saw Jen was in here. Jason Johnson, HVAC blogger. Jason, we're going to be talking about chillers, and I don't know, John always shows up. I know he's a supermarket tech. So we do have a special guest. We have Brett Wetzel from the Advanced Refrigeration podcast and the Cooler Heads podcast. So let me bring him on real quick. Welcome, man.
What's going on?
I'm doing pretty good. How are you?
I'm excited to actually be here.
Really?
Yeah.
Well, I'm excited to have you on. I'm glad that you kind of like volunteered yourself. Happy to have you on because we're going to talk about refrigerants, CO2 systems, chillers. You know, this guy does everything. If you want to introduce yourself a little bit, I know a lot of people probably know you from the podcast, but I know you do other stuff. You do trainings. You do, like I said, you do a lot of big commercial work. So do you want to talk about like your experience, stuff that you do?
Yeah. I mean, not anymore. I have computer hands now. All I do is sit on the computer all day.
Behind the scenes, you know, you're training the next generation.
I am. So my name is Brett Wetzel. I've been in the industry now, I think, 21 years. Fuck, I'm old. I've worked on anything from, residential mini splits, tons of chiller work. I worked on ammonia for about 5 years, and then finally ended up. Shut up, Brian. And then ended up going to do supermarket up in Connecticut. I moved up to Connecticut for a little bit. Did supermarket work. Ended up like building their energy management department, doing a whole bunch of stuff. And I've never done. At that point in my career, I'd never done like specifically energy management. And they're like, "Do you think you could do it?" I'm like, "Sure." Yeah. So I remember getting the first big ass job that I ever did. I get 7 pallets of energy management equipment, boards and just everything, right? And I was like, "Well, where's the prince?" He's like, "Well, it you know what has to happen, just make it work." I'm like, "Okay." So I was up in Albany for I think almost 6 months I was building the Whole Foods up there. That was fun. Yeah, I don't know if you've ever pooped on a porta john at negative 20 degrees up in Albany, New York, but that's just fun.
Hey man, I'm in Texas, South Texas. I know you're from the upper North Texas area. Yeah. Are you in Dallas?
I'm in Dallas currently. Yeah. So I grew up in Pennsylvania, moved up to Connecticut. And then after I herniated some discs shoveling snow. So I realized then how much I hated snow. So I was like, let's move somewhere warm. So it was either this or Arizona. And I really didn't want to live in an oven. So I decided to hit Dallas, and I was thinking, maybe Houston. And I was like, nope, it's humid. It's really humid. It's like Florida, rains all the time.
Oh yeah, that one's worse because we get the high humidity and stuff, but we don't get as much rain. But it's hot as hell down here.
Well, you're Corpus?
Further down.
RGV?
McAllen, yeah, RGV.
Oh my God. I was down in Uvalde training because I when I moved here to Texas, I got hired for CoolSys, and I've been with CoolSys now, I think almost 8 years. I got to be a level 6 technician, moved up to a level 7. And then I was getting bored, and, they were complaining about, needing help in other branches. So I took their trouble stores. I'd go around to all their trouble stores. Basically, I'd be on their ticket, and I would train with the people that were having the issues with there. So you're doing a bunch of things at that point, right? You're resolving the issue that's been an ongoing issue, right? You're educating the people that you're around. So now they know how to fix that thing. They understand how it's supposed to work, the sequence of operation and stuff like that. And it worked out. So that's all I kept doing. I was driving around from RGV to Corpus to Rio Grande to Houston. I was going as high as Oklahoma, Tulsa, Oklahoma City, just all over the place. And I was starting to get bored again because that's my problem. I get complacent, and if I'm not challenged, it's not fun. I like puzzles. I like figuring shit out. And I was gonna move on, and I was given the opportunity. They were like, "Well, what happens if you would do what you're doing now, but like for the country?" And I was like, "I'm listening," and then we just started talking about it. And that's originally what I was supposed to be doing. I was supposed to be traveling all the country, just fixing, fixing stuff. And then because like I said, you go out there, you train those guys up on the issue that they're having. Now they're smarter with what they're doing. The store is going to be better, well kept, right? So they're going to have less service calls. And then you just keep beep bopping around the country to do that. And I did that a couple times. I went out to Georgia, resolved some stuff, and then somehow, some way, I keep failing upwards. And my boss was like, "You want to be in charge of all the training?" And I was like, "Sure, let's do it." So I had some ideas of what I wanted to do. I started making videos for the employees. I have a database of probably 200 gigs worth of information that I've saved over the past 21 years. Um, you know, just made a website for the technicians. So like not corporate fluff garbage that they don't need to know, right?
Yeah.
Guides, leak detection forms, like anything that they would actually need. The only thing I added in there for fluff was basically anytime an article is written about one of our technicians, I'll put that up there because I just think that's great. You know what I mean? When a technician does it, we had a technician that saved a baby. We had another one that broke into a house and saved a couple that the house was on fire. Like really cool stuff. Yeah. So that's the kind of stuff we put on there for recognition because like, man, you're badass. Like, why not put it up there and celebrate you? You know what I mean?
Of course.
So yeah, so now we have the company I work for, CoolSys. We have I think over 2,000 technicians at this point. 4 training centers. We have one in Fullerton, California. We have one in Houston, Texas. One in Jacksonville, Florida, and one in, I always screw this up, Menominee Falls, Wisconsin.
Wow, that's awesome. So you do the training, you do the what do you call them? The courses, the the presentations, stuff like that.
Yeah, we have courses for each level for construction and what we refer to as our CNI, commercial industrial group. We're working on curriculum that is going to be taught this year, which is part of the expansion project that I'm doing for the other facility there in Texas, and basically trying to make sure everyone is as well trained as what they can be. Coolest is a big company. We've acquired a lot of different companies. So it's not just the supermarket stuff that they always used to do. They're building and elaborating. And, I had a conversation with someone about wanting to put VRF in their curriculum. And they're like, we don't really work on VRF. And a couple weeks later, they got a customer like, "Hey, can you work on VRF?" And so I got a phone call and they're like, did you get that equipment yet for the VRF? And I was like, "Not yet. I'm working on it." I'm talking with a couple manufacturers trying to grease the wheels a little bit and see if I can get the stuff in there. But I don't know if anyone's aware, but like Daikin, Texas Air Systems, LG, Toshiba Carrier, a lot of these places that do like the VRF and the mini split, they actually give free training. They have Daikin and Toshiba Carrier, have a training facility in Carrollton, Texas. They both have one in Carrollton, which I thought was funny. And they also both actually have one down in Houston. So
nice, interesting.
Yeah. So go ahead.
Yeah, we don't work on a lot of that stuff. That's why I wanted to have you on, is to talk about, because some of the guys in the chat, like I said, they do a lot of the heavy commercial, industrial stuff, supermarkets. I never got into that. I do the light commercial stuff. So I'm in my own little niche.
Yeah.
I work in restaurants, doing light commercial, like walk-in boxes and under counter freezers, ice machines, stuff like that. So all that stuff is interesting to me, and it's cool. Like you said, the Daikin and all these different manufacturers offer the free training because why not? Everybody should have or should get the knowledge if it's at their disposal.
Well, that's the thing. Like, well, and this is the key. Like, if ever I'm trying to talk to a manufacturer, I was like, "Are you sure you don't want to give me that controller? Because if you give me the controller, I can make some training around it. If I make some training for it, because I always say the same thing. I'm like, you realize the lack of your training on your piece of equipment makes your equipment look like a piece of shit." And he's like, "Fair enough." So like, I'm literally got controllers falling out of my desk here.
I'm dealing with one right now, the Heatcraft. I'm sure everybody in my chat already knows because I've made like 5 videos on them. The Intelligent. I'm not getting good answers on them. You have one of those too, don't you? Okay. So I didn't get to go to their booth because I went to the AHR and I think they were there. Or I've seen some videos that they're doing or they're pushing it more. And they have like, I think even now, like a kit that you can add on or something to an existing, or I don't know how that works, but they're pushing the Intelligent more.
Yeah.
I've had issues with them. Now, I've had issues with the board. I don't know why they don't give out signals sometimes, and I'm trying to do everything I can, check them
Signal for
uh,
what? Because I know the
for the
beacon. I know the beacon.
EEV.
Oh, okay. Because I know the beacon, because I haven't really got to really dig into it. I know it's a lot, really, really comparable to the beacon system.
Yeah.
So you have that usually that 24 volts that actually gets derived from the actual board that goes all the way upstairs, to the actual condensing unit to give that command. A lot of people get away with that with not wanting to run the wire. So what they'll do is there's a certain resistor that you can put in there that fakes it out. So whenever it does put the voltage out, it thinks that it's actually the contactors in, and you can actually make that system a straight up pump down. I like this system, but my problem with it, unless they changed it, where if it's not able to pump down between 2 and 10 psi, it's usually where they want you to set the pressure switch. That's not a cool thing, man. Like, not every single compressor can pull down to that.
No.
So this is a case in point. So I had a medium temp system one time when I was up in Connecticut, right? And the thing kept going off, going off, going off. It had a peanut peanut low pressure switch. And the peanut low pressure switch basically you can't change, right? So this compressor periodically throughout the summer would go off on high head. Periodically every 2 weeks when it would get above 90 degrees. And what had happened was I looked at the compressor. I looked back before I was using the big Copeland blue book, and in there will actually state what pressure that you're supposed to set the low pressure switch for. The reason why is because if it goes any lower than that, it's working outside of its operating envelope and says, you know what, I'm giving up the ghost. And then basically it will go off on internal, and then you got to have a bag of ice because it's working outside its parameter. It's working too high of a compression ratio. And that's part of the problem I have with a lot of this energy efficiency stuff, where they end up driving the head pressure so freaking low, which inadvertently takes your compressor, right, and actually oversizes it. If you didn't realize, if you have a compressor, let's just say it's 10 tons, okay, and you're running that sucker at 120 degrees saturated condensing temperature for the pressure, and then you put it all the way down to 75 psi, that compressor will actually increase in capacity by 25 to 35%. When that happens, you have more ponies, right? What's going to happen to your suction pressure? It's going to go even lower. So I know they're trying to get as much energy efficiency out of it because of the DOE, the Department of Energy, but it ends up causing a shit ton of service calls.
Yeah. Well, as far as my issue, it was just with I don't know. I have to swap out the board and then it works. It's just I don't get that voltage to the EEV. And at first I thought it was the EEV, but it's usually never those.
Also, make sure this L part, is always facing towards the L in Corel.
Okay. Oh, yeah, the orientation.
The plug can only go on one way, but you can force it on there, because I've had a couple calls on new stuff, and they're like, yeah, it's broken. I'm like, it
goes on one way.
Yeah,
I've read through the manual and everything, and I even talked to somebody from Heatcraft or one of their distributors that we went through the whole troubleshooting process. But, I went through all that, and I was like, you know what, let me just throw on another board, F it. Put it on and it worked, and I've already had like 3 of those calls. So I don't know what it is, but like what we're talking about is the whole training thing. I want them to give me some answers. I want to get some training on them, and I think that would help or benefit a lot of guys, because when I posted those videos, I got a lot of comments, I got a lot of messages, and we even have a company that's like 3 hours out. They're confused too, and people that message me, they're like, oh, I just had the same issue and this and that. And they're like, well, I watched your video and I got through it. And there's not a lot of training on it right now, as far as I know.
Yeah, it's amazing that you say that. So there's a certain manufacturer I went to go visit out in Georgia, and there's like 10 of them out there. So I'm good here saying this, but I didn't realize that a lot of the manufacturers. Yeah, I even made my own shirt though.
Oh, no way.
Up here it says Joe's great. Joe's great.
Oh yeah.
So anyway, so I was talking with Kevin, and I was like, hey, I'm going to see, this manufacturer. If I disappear or something happens because you have said something shitty about this manufacturer, if a rack falls on me or something like that, what happened, right? And I was talking to some of the people down there, and he's like, yeah, we actually have advanced refrigeration memos. I'm like, what? He's like, yeah, if you guys say something bad about our equipment, we send it to our engineers to make sure that there's a problem.
No way, man.
So like, I guarantee, I mean, probably Heatcraft is like that fucking Adrian guy. He's screwing with, you know,
Well, I was going to tell you afterwards, but I actually got an email from them. No, but they were super excited and they're like, hey, I would love to make some content, this and that. And we had a couple of exchanges, and all of a sudden they ghosted me, and I'm like, oh, it's probably those videos, but oh, whatever.
fucking QRC.
Yeah. I mean, it doesn't bother me. I'm putting out the stuff to help others, right? If they have the same issue, then they can go through it, kind of go through, you know, maybe the steps that I went through, or skip the ones that I didn't need to do, because I actually replaced the EEV, and this was honestly the first one that I had seen. Because our customer, because we do a lot of mechanical down here, so like we're way behind. We never even saw the beacon system or anything like that. So I'm used to mechanical all day, and when I saw that, I immediately, because I even went through like the test mode and the service mode. Like I try to do everything I can and check for the voltage. And I got everything, and I was like, okay, this EEV has to be bad, or something. And I don't have that little. I know they make like a magnet where you can manually
well, if you
turn them or
loosen up,
anything.
yeah, but if you loosen up this nut and take this off, you can actually twist the stator on there, and it'll actually open up.
Just manually?
Yeah. Like, so if
I was told we needed a magnet, like a special magnet.
Take it off next time. It's a fucking magnet inside here. So if you twist this, I can actually make this valve fluctuate, open and close. So, you know, sometimes it won't do it, you know, if the valve is mechanically bad. And that's the other thing. That's why I grabbed this again. So one of the things I do want to tell you, all these valves are bipolar, or by flow. You can actually have flow going this way and flow going this way. But they, you know, they really want you to feed the liquid into here, into this side. Okay.
Yeah.
The reason for that is if you were to go the other way, then that means that this would get colder, right? If this would end up being the suction, this is where all the gears, this is where all the electric is. So it causes excessive condensation in there and will actually prematurely fail the valve. It's feasible. It will go in either direction, but there's the reason why they want you to do it a certain way, because basically by putting in liquid here, you're warm and then it doesn't get cold until the end here. But if you run the liquid in here, it's going to start getting cold down here, which means this whole assembly is going to get cold, which means you have more of a chance of potentially screwing up the valve.
Well, I did a whole bunch of unnecessary steps because I thought it was the valve. I replaced it. So the thing is, when it failed, I think, pump down. So it was closed. I couldn't open it. And I replaced it. And I believe, unless I have it backwards, but I believe they come already like in the open position.
They do.
When you get them new. So I thought I fixed it because it ran and it worked. I left and I came back and they said the machine is freezing and never turned off. So then, okay, I was like, well, it's not the valve. We replaced the board and it fixed it. So, and then just based on conversations I've had with other guys that are, you know, that do these electronic expansion valves, they always tell me it's really never the EEV. They hardly ever go out. So then, you know, on my next calls, I kind of I kept that in mind. And it's usually something with the signals. I'm not getting a signal. I've had relays go bad and things on the board. So it's usually like that kind of issue, which kind of sucks because, you know, I love their equipment. They're super easy to install. The ones that we have, like, they don't communicate with the condenser. The condenser is just a nice, you know, new microchannel contactor. You know, it's real simple. We don't have anything that communicates back and forth.
Okay, so they got rid of that then. Thank God.
I don't know. We haven't seen that because our customer orders their own equipment for that one, and they have gone with Intelligent and Heatcraft, and usually it's a mechanical condenser, and then we just hook up the Intelligent evaporator. Of course, you have to make sure you set it up right too, because it's going to ask you if there's a condenser communicating with it or anything like that. So.
Well, that's why I look, because I couldn't remember. I know that the beacon, you know, had that wire that connected. There is an output on the blue terminals all the way on the right. and that's where it should be setting that signal up. But like I said, sometimes you'll see if someone didn't want to do that because it was an old install that they were just changing into a beacon. They're like, I'm not running a wire up there. They'll put in a resistor up there and basically just set it up as a regular pump down.
Yeah, and I learned that too because it's also how you set it up. Because I think I went through one of the first ones with them over the phone, or I think they text me. I tried to reach out to their customer service, and the guy ended up texting me, and he was able to answer my questions through text, which was cool and all, but yeah.
I'm sorry, I'm just showing Joe.
Yeah, so we put a few of those in. Like I said, they're super easy to put in, especially that way. Like it's not communicating with anything or anything like that on the roof. You just put it in, it's self-contained, and it just goes off on like the solenoid, right? The EEV is the solenoid and the expansion valve, 2-in-1. Your compressor will shut off on pressure switches and all that. They're super simple. The only thing is when they go bad, at least the board, you're kind of shit out of luck because there's not much you can do because that controls everything.
Yeah, I mean that's the only thing.
That's the only bad thing. Yeah.
And there'd be a way around it, but you'd have to play around with it. So Sporlan makes a bipolar stepper board, and there's jumpers on there that on the multiple one that you can actually select how many steps, right? Because like Sporlan SER valves, AA through D are all 2,500 steps. If you have EPRs, like a CDS 9 through 20, I believe is 6,386 steps. So like they all have their own steps. So you get this one board and you can actually select how many steps that thing is, and then you can give it a comparable signal, and it'll step it based off of that.
Okay, because we had one that there's ways around it, because we had one that the relay for the fans gave out just randomly, I think, and I just put in because it was a freezer, I just put in a what do you call it, the fan delay mechanical on the side, so that they would cut in and out, and then we got them going that way until we got a new board in. But it's just, I guess you got to get creative with this new stuff, because a lot of it's like, the board goes out. That's kind of the head, the brain, everything that it does goes through there.
Yeah, 100%.
Man, I don't know if you're reading the chat.
I saw Joe was in there.
Yeah, Jen said you're thirsty AF. Oh, here we go. We got Jonathan. He's asking, where's Kevin?
Actually, it's funny. So when we do like the podcast, we do record the video, but we never put it out usually, unless there's stuff that we're being like someone's showing us stuff. And usually Kevin, I don't know what it is, the room that he's in, he looks like he is like the Unabomber. I'm just gonna say it. It's very, very dark. You can't see him. He doesn't like doing live stuff at all. Like like the first time we did AHR in, oh my God, Vegas, when we went to Vegas, like he just, I don't know, he just doesn't really dig doing like live stuff. You know what I mean?
So purposely he doesn't like to, or he does that setup, because I've seen it, what you're talking about on the video or the live stream when he comes out. Is that on purpose then?
I don't know. Because I told him, I was like, I'll get you a fancy tween girl, light for yourself. You can actually see. He's like, no, I don't want that shit. Okay.
Yeah, I've seen that. I lost the comment, but someone was asking, would you rather work in 120 degrees or negative 20 degree weather? Because you've seen both. What's the coldest? I have. What's the coldest you've been in?
Negative 27.
Oh, okay. Yeah.
There was nut high snow on the roof, and there was a rack it was a critically charged rack, and it was low on charge, and the valves that did the critical charging aspect of it weren't really working all that well. And I had 3 cylinders of 407A, and I couldn't even get the 407A in the rack because it was too cold. So I had to take
Yeah.
all 3 cylinders and throw them in a slop sink to warm them up with warm water and finally get in the rack. And I couldn't get the head pressure above, it was delving like 25 to 35 pounds. It was just that cold and that fucking windy. The head pressure just wouldn't build. And
I
so,
can't imagine that because, like I said, down here it's warm like all year round. I know
yeah.
you guys up there kind of do get colder weather than down here, and it's funny because Texas is so big that where there's different like areas. Because I had Efren on the other week, and he's from the Austin area,
Mhm.
and he's like, the attics up here are not as bad as they are down there because he's been here before too.
Yeah.
And I'm like, yeah, dude, I just moved into this house not too long ago,
Mhm.
and I had to get in the attic a couple times, and I'm like, oh man, like I see people online posting and they're in the attics recording and stuff, and I'm like, if I go in mine, like I start like buckets of sweat, I'm already like ready to get out of there. But it's different because of like the humidity, the area that you're in, and we don't get a lot of cold weather. So that one year that we had that freeze, that real bad one a couple years ago, that I think we had like, I think we've,
It was
I've never seen
February.
it.
It was
Yeah, I've never
February 2
seen
years
it.
ago.
I don't think I've worked in it personally, but that year or like prior to that, but that year we were under 20 degrees, and I've
Mhm.
never worked in that. So I'm out there, of course, there's units out there that like, I don't think they leaked out or anything. It's just that nobody properly charges them by weight. They put them in and they charge it up, and it works on the
You
hottest day. But then when it gets cold, they start acting up for
you
that
talk you
charge.
talking about split refrigeration system?
Yeah, like
Or
in a
you know?
walk-in
Yeah.
box, because they have receivers and all that, to hold the extra charge. But
Well, you're supposed to. I mean, like, as if you don't obviously if you don't have insulation on there, what you're supposed to do is fill that receiver in summertime up to
yeah,
about 60%, because then that 60% will actually then go down to 15 or 20% when it goes in full holdback mode, right? And it's cool,
yeah,
like, because in commercial refrigeration you have graphs for everything. But to answer your question, man, -20 sucks, but so does plus 120. They both equally suck. At least when you're -20, like, I look like I look like a kid from A Christmas Story where I can't put my fucking arms down,
yeah,
so I'm so bundled up. Um, but no, 120 sucks. I was actually working down in Uvalde the one time, and I was
yeah,
asking the cats down there. I was like, "Cabron," I was like, "What do you do?" I was like, "I can't. I'm sitting on this unit and my ass is on fire." Like, I tried kneeling. I'm like, no, everything was on fire. No matter what I
yeah,
do,
yeah,
like, cardboard's your friend. He's like, I don't know what to tell you, man. It's Uvalde. What are you gonna do?
yeah, man. Because like that time, I had to put in some charge, some 404 systems, and you got to warm up that tank one way or another, just to get it in there. And trying to charge it in that kind of weather
Hmm.
kind of sucks. But yeah, I didn't used to do that. Well, I would always try and weigh it in, but once I learned the receiver, I guess, trick, usually I was told like around 3/4, something like that. So
All right.
check it, pump it down, check it. I started doing that, and that's a little easier, especially when you're just trying to top off the unit. They might not have a leak; it just probably was never charged properly. I ran into that a lot. It's funny because, like, we'll pick up a customer, the unit's fine all summer or whatever, and then like all of a sudden in the winter, like they start calling, like all of them are down or whatever. So
Well,
it can,
that's what I was saying about commercial refrigeration. They have so many sensors on everything. It's really
yeah,
amazing. Like, so one of the big box stores, they put pressure transducers on their single systems so they can monitor it, right? So you'll see it where the head pressure will be fine during the day, and then as soon as as soon as it starts getting colder out, what's going to happen? It's going to start jamming more refrigerant into the condenser, trying to raise the head pressure rate. And then you'll see the discharge pressure start delving down, and it'll be like 10, 15 pounds right below of what the head pressure headmaster is set for, because it's
hmm,
bypassing like a bastard trying to fill up that receiver, but it just doesn't have enough head. It can't, there's not enough refrigerant to back it up on that unit. So it's really neat. You can see, like, as the temperature starts going down, you can actually see the temperature of the box actually start going up. And so if you see that happen with the pressure transducer reading underneath the headmaster, 99.9% of the time, it's undercharged, unless the headmaster is totally just screwed.
yeah, yeah. I've seen. a lot of that stuff in the winter.
Hmm.
And you kind of like you get, or you have a better idea the more you see it. Um, where was Jennifer? The hottest she's worked in is in, I guess, 90 degrees.
Yeah, she lives up in like Deliverance, Maine.
No, like we had what are we, June already? Like I think early May or even April, we had like 100-degree weather already, and it's AC season. And today we were doing, of course, one of our customers, like I've been bugging him and bugging him to do maintenance, and then like of all days, or of all months, they decide, oh, this is the month we want to start that. Can you do it already? That was hot as hell. And to me, like I'm out there trying to, and I cover up. I wear the sleeves, big old hat. I've already learned my lesson. I used to come home like toasted and stuff, and it helps. But the sun, like especially down here, or just in Texas in general, I know, like you said, Arizona is another bad one. California can get some heat waves too, and man, I was just like so tired after that maintenance. I mean, it's just maintenance, right? But I was like so tired just because of the sun.
I was that one chocolate plant I worked at. They had this thing called the tunnel. It was a tunnel that was probably about 65 feet long. It had probably 25 4 or 5 fan bone evaporators that were staggered. And so this chocolate plant, they basically took the raw bean from Guatemala, roasted it, got it down to its chocolate powder form. But one of the side products actually made in chocolate production is oil, cocoa butter, right?
Oh, okay.
And so they have these big vats of hundreds of gallons of what they call hot liquor. It's just basically melted chocolate. So it might be 100 degrees in Pennsylvania, but inside that mother, it was like 120 degrees. And I was dying. That it was just awful. It was just awful freaking hot. So I'm like, what can I find today that's going to make it a little bit easier on me today? Because like I would literally just go there every day. They had over 50 to 75 pieces of equipment. Like I said, ranging from a mini split to a packaged frick ammonia chiller, right? So I'm basically bebopping around trying to figure out what I'm going to do. I'm like, I'm going to go change fans in the tunnel. So I was already sweating hot. You know how it is. You get kind of drowsy when you get that hot. And I jumped in this tunnel. The tunnel set point would be staggered from like 65 to 55 to 65 because it basically was trying to pull the humidity out and cool the chocolate fast enough, or I'm sorry, not too fast that it actually ends up sweating when it comes out. So that's how they do. They would stagger the temperature. And I remember laying in there. I was like, I closed the door behind me. I was like, oh, I got my flashlight in here, whatever. And that was the last thing I remembered. I woke up and I'm like, oh my God, I'm fucking freezing.
Dang.
Where the hell am I? And I saw the little bit of light and I'm like, no. Because like basically you had this big stainless steel sheet that was the big conveyor belt. It was probably 4 feet wide, and they had this big press that would basically give you like nonpareils or like Hershey Kisses or stuff like that, like on this one production table. And I literally, I don't know how long I was out for, probably maybe a good 20 minutes, but it was inside the factory. It was about 125 that day. It's just some of these places you just get brutal. I mean, I don't know how you do where you live all the time. That's an oven. That's an oven, sir.
It's crazy. Yeah, you've been down here before, right?
Yeah.
You're familiar with the valley and stuff.
Mm-hmm.
It gets pretty brutal. I feel like it gets hotter every year as well. But yeah, like today, like I was just doing maintenance, a lot of maintenance. I had help. My brother was with me. We tried to knock it out, but I was like so tired afterward, like sleepy and all that. So
I remember my first summer here from Connecticut, and I was dead. I was absolutely dead. And I think my team lead, because I'd never been a team lead because I didn't want to, because like they have to deal with dispatch. I was like, dude, I'll diagnose everything all day long. I don't give a shit about that. I was like, I just don't want to deal with the dispatch. You figure out where I need to go and where everyone else needs to go, whatever. And I remember it was 115 in DFW, and I think he quit probably 6 or 8 times that weekend because we'd knock out like 6 calls and all of a sudden 8 or 12 would come in. He's like, I'm quit. I'm fine, and just this kept going on. So at one point, I told everyone to go home because I had started a little bit later because I had worked late the night before the day on call. And I was like, dude, what, just I think it was about 2 o'clock in the morning. I was like, dude, just have everyone go home right now. He's like, well, what are you going to do? I was like, I'll just take all the calls until the morning. So I worked until about, I think 10:30 in the morning. And then where I finally started, talking them up. But it's one of those things where that heat is just so damn brutal. And I thought, I'd be fine just drinking a whole bunch of water. No, you can't drink that fast, especially when you're that exhausted and that tired.
Yeah, man, it's well, blogger here was like asking if we use sunscreen. You need to do whatever you can, cover up. Like I was gonna do the sunscreen route, but I cover up long sleeves or arm sleeves. I have my gloves on all the time. I have a big hat with a neck guard. Anything you can, but then also just take the breaks, get out of there. I went to my van a couple times just for 5 minutes, cool off. And some guys were talking about attics up here too in the chat, and attics are even worse because it's a confined space. If you're by yourself, nobody knows if you pass out up there or anything like that. So take a break. The heat is no joke. Yeah, see, Young over here. Sunscreen is for weak body.
Yeah, I like using the sleeves, honestly, like the cooling sleeves and stuff like that. I'm Irish,
Yeah.
so I kind of tan a little bit because I got a little bit of German in me, but for the most part, I'm kind of like my mother, where I just freckle, and like all the
Oh,
freckles
okay.
make a tan. So, but yeah, I have to do something, otherwise I burn, and then I'm a little girl for at least a week living in aloe.
Yeah, man, I used to get like crazy tans. I just try to cover up. Let me look at the chat real quick.
Yeah.
Brian over here, Brett, what PSI do ammonia chillers run?
I mean, I guess it would be like whatever saturated that you're trying to maintain, right? So, you could have an ammonia chiller that's doing like a brine solution, right? For like an ice rink. So you could have like a 20-degree saturated. I'd have to look at the pressure off the top of my head. It's really going to depend on what you're trying to pull that temperature down to, right? If you're trying to do, I mean, there's some ammonia systems that do run into a vacuum, to get a lower saturated suction. But fortunately for ammonia, ammonia systems actually have what's called a purger. So, not that it's good practice to do that, but you can just leave the air in there and just let it ride, because the purger, as long as it's working, will theoretically work. Obviously, it's not good for the system and would not recommend it, but that purger's there because you can, when you're using a vacuum pump, you got to remember ammonia will eat through anything that's brass and copper. There is no brass and copper on any of these ammonia systems. It's either black pipe, stainless. Yeah, that's really about it. And so you can't use, even the expansion valves, like the mechanical expansion valves, are stainless steel. So it'll eat through everything. So when you're using like any kind of vacuum pump, whether it be JV, Ritchie, whatever, that vacuum pump, when you're doing ammonia, usually has a lifespan of about a year, maybe 2, because the all the brass workings that are inside that vacuum pump end up shit in the bed, because you're basically deteriorating. Ammonia is a nasty thing. It's not only you can get your regular burns that you would, but it loves moisture. And it loves moisture so much that, so when you're working on an ammonia system, if you're going to pump down a system, what you would do is pump it down like you would any other system. But because it has a GWP of 0, you can just blow it, but you can't blow it, because then it will kill you. So you actually take a 3/8 hose coming off the system, off of whatever vapor, now that you're pulling that you just have nothing but vapor, and you put it in a 5-gallon bucket full of water. And basically what will happen is it'll have this chemical reaction. Like if you put too much vapor too quick into a 5-gallon bucket, it will start to boil.
Yeah.
Because of the chemical reaction. It loves water. But yes, Brian, answer your question. It really depends on what saturated that you're trying to run, right? If you're trying to I'd have to look at a PT chart in order to be 100% sure. But
yeah, no, PT chart's your best friend, because we have to deal with so many things. Because I always get asked that too. Ryan, do I sound better? He pointed out my mic wasn't even working. I'm still learning all this stuff, the whole podcast, but I always get asked that, and I used to work with a lot of guys that would ask me like, what should my pressures be? What should my suction pressure be? And I'm like, I don't need to, or they would tell me what their readings were, and I'm like, I don't need to know that. I need to know What's the
Saturated.
temperature? Yeah,
Saturated.
saturated temperature, and then give me your condensing temperature, because I can give you way better tips and troubleshooting stuff or diagnosing versus like numbers, PSI numbers.
Well, so did you do HVAC first before you did refrigeration, or was it the other way around?
I went right into refrigeration. That's what I
Okay,
mostly
so
do.
that's why. Because any other cat that you talk to, typically when you talk to someone that does HVAC, and you're like, what do you have? Well, on a 100-degree day, your suction pressure on 410A should be about 120 pounds, and the R22 is about 68 pounds. So like that, I can tell
Yeah.
right away when you just do HVAC. When you talk to a reefer guy, not that kind. So Jason Johnson, don't get excited. Basically you're always talking saturated, like, and I do it all the time because there's 400,000 different freaking refrigerants, right?
Oh yeah.
So remembering all that PT chart, like it's certain numbers I can remember. Like I can remember what's the 18 degrees saturated for 449 is 43 pounds, and it probably because I programmed it 60,000 times. But like, give me saturated. I don't need to know pressures. That's not going to do me any good. Just give me the saturated, and I'll be able to help you out.
Yeah, because even the gauges, like, and we've had this conversation, or I've had it with guys, and about digital. It it's hard to recommend analogs. I know Yellow Jacket just came out with one that has like the 440 whatever, I think, refrigerants on it now.
Mhm.
And for the longest time, I was like, yeah, analogs are the way to go, and you should learn on that. But it's getting a little harder now because we have so many different refrigerants, especially on the refrigeration side. And I mean, at this point, you need to know your saturation and a PT chart. So you're going to be using your phone either way. If you go analog or whatever, you need a PT chart,
See
either
this.
physically or like on your phone or something like that.
See, this is an argument I have with Kevin all the time because I'm like, I think a new kid should have to read the freaking pressure. Just give him a set of pressure gauges, no temperature on there. Make him use either the PT chart or the phone, because I
Yeah.
think people get kind of complacent. Like, oh, it says 5 degrees of superheat, but I've had guys give me that, and they're like, well, I don't even have the refrigerant set up right, or you know what I mean? Like,
Yeah.
oh, I had the liquid in the suction temperature sensor switch, so I had like 8,000 degrees of subcooling. Like they just being able to hook it up and being able to understand those numbers. I think it has more value than just
Mhm.
letting gauges do the work for you.
Yeah, I mean, they kind of do. I have the field piece set. I'm, but I feel like I paid my dues. I already have that under my belt, that I had the analogs for so long, and it does make it easier. And I guess you can get too dependent on it, but at the same time, the convenience of having all the refrigerants in there, and then they'll update it, through software updates to add more to it. Um, that's the part where I'm like, well, they can be helpful, but if not, analogs, read the number, but then go get a PT chart, read the temperatures, and go about it that way. But yeah, we have a lot of refrigerants now. We like down here. I think we're still dealing with 404.
Mm.
I never saw like R12. I never saw I don't know what it was, like
502,
502. Yeah. I saw a little bit of R22. There was some systems like that we had that like RTUs. For the most part, we were able to change them out. A lot of 410. I have not seen the new ones like 448, 449, any of those yet. We're
They
still dealing with
they have
404.
them down that area. They do a lot
I
of
know.
the bigger supermarkets. I'm not going to say it, but the big one in Texas, right? That
Okay. Yeah.
they're so on trying to go sustainable refrigerants. So like currently um, they're doing what's called a cascade system. So you have an HFC or an HFO for a primary, right? So they're either using 449, 448, or 513A, which
Hmm.
essentially is just R134A with a little sprinkle of R1234XY. And I'm
Oh,
really
okay.
not making that up. That's
Yeah.
basically what makes that thing an HFO. It's that
Yeah.
little bit of
I didn't think that was real when I first heard it. I was like, really?
someone was
Such a
like,
weird name.
stop screwing with me.
Yeah, I know.
1, 2, 3, 4, 5. That's amazing. That's the kind of combination an idiot has on his luggage. Love
It's like
space.
that passcode that everybody tries to used 1, 2, 3, 4. Yeah, we don't see those, but I don't do a lot of supermarkets. Like Coca-Cola is also one that does some different stuff too, because I work in hospitals, and they got new equipment, whether it's Pepsi coolers or Coca-Cola coolers,
Mhm.
and the label. I'll read the labels just because I'm walking around doing like maintenance and stuff, and I just want to know like what it is.
Mhm.
And they have all these weird refrigerants and stuff that I haven't seen yet. So I guess they're on top of it too. I guess the bigger companies that are going that route, but I still see 404, 410, and then all the R22 that I did see, we did convert to 407C. That's
For
what
the
that's
HVAC, right?
that's what we went with. Yeah.
Okay, but for refrigeration, I would recommend going for, well, I mean, I'd skip the 407A at this point, but just go to
Yeah.
the HFO, the 448 and 449, because that's the thing. Like with all these new things, the EPA snap band. There's so many different things that you have to watch for, because certain different types of refrigerant can only have so much. So I think right now propane is up to 5 grams, and I think they're contemplating going to 10 grams. The thing about propane is it actually really does have a very high BTU per pound, as far as number. Like you could actually run a whole rack that would typically take 200 or 300 pounds of a normal HFC or HFO, and replace that with 50 or 33 pounds of propane, and it would
Yeah, it's
actually
crazy.
run your whole freaking store. It's freaking ridiculous. Like, so I deal a lot with the North American Sustainable Refrigerant Council. They put on this thing down in Irwindale. It was all about sustainable refrigerants. So they went over, there were 17 different manufacturers, from AHT to Zero Zone to Husband to Hill Phoenix to let's see, AHT. True was out there, because there was like 2 or 3 people doing propane, a couple different manufacturers of energy management systems, and they talked about all the different types. So you have a lot of times what people are doing now, especially with the AHT stuff, which is, it's really cool. The stuff gets put together pretty easily. They have these micro distribution systems, so they have the compressors out there on the sales floor. But if you had a whole supermarket filled with a whole bunch of self-contains, it's going to get really hot in there, right?
Yeah.
So what they do is very, very easily, is they take a glycol loop and run it throughout the store. And every single one of these self-contains, instead of having an air-cooled condenser, now it has a water-cooled brazed plate heat exchanger. So
Gotcha.
then you have a circuit setter on there, you set that, and then so in the summertime, you expel that heat outside. And then depends on how advanced you want to get, Adrian, instead of wasting that heat and blowing it outside, let's just say you're in the middle of summer and your air
Mhm.
conditioning is just tanking the temperature down, and it's cold in there, but it's humid, right? Because it didn't actually
Yeah.
pull out the moisture. So you want to add a little bit of heat in there to make up for that. So that's what they do. They'll actually divert the glycol that they're using to go out to the dry cooler outside to expel the heat off of the condensers. And instead of that, they'll divert the flow to an inside air handler, and then use that heat that they're actually getting from all the propane or whatever self-contains they have there, and basically utilize that heat to heat up the store.
Well, yeah, that's a whole bunch of stuff that I haven't seen. And it's interesting, the like even what you were talking about, the capacity on all that stuff. Like people are like, because like Jennifer right now was like, ISO, what did she say? Something goes boom. Everybody's afraid of R290 and all these propane refrigerants, but in reality, it takes less to do so. But I mean, we'll see where it goes. Like the only R290 I've seen is on under counter coolers and freezers, and they have about 2.5 ounces, something like that.
Yeah. Yeah, so you have A1s, which are like your 407As, your 407Cs, your 407Fs, 404A, 507, 452, and 134A. And then you have your A1s, which are still non-flammable. So your 448s, your 449s, basically all your HFOs, your 450s, your 515s. Then the next one you have is your A2Ls, which would be your 455s, your 454s, and your HFO. Yeah, 1, 2, 3, 4. It's YF. I'm sorry, it's YF. I was wrong. And then you have your naturals, which would be your 744. your ammonia, or I'm sorry, your CO2. You have your 290, which is your propane, and your ammonia, which is 717. So ammonia actually has no GWP whatsoever.
Oh,
So no
okay.
harm, no foul. We're back in the days
Yeah.
of R12, and you can just blow it, right? Same thing with propane. Same thing with CO2.
Yeah.
CO2 has a global warming potential of 1, and propane is think it's 3. It's 3. But like you said, there's also limits with how much weight that you can actually have, right? Based off of the stipulations. We just had a conversation the other day with Joe Summers from Emerson. We were talking about A2Ls,
Mm-hmm.
and because I asked him, I'm like, can you retrofit any of these systems? He's like, no, not at all. I was like, well, why
Yeah.
not? He's like, because a lot of the stuff is designed specifically for that, because the more flammable, right, the more precautions they have to take, right? So different relays, right? Instead of having open relays that might be able to spark, they want something
Yeah.
enclosed. So that doesn't happen. What else did he say? There's certain components that they had to get tested. No flares, not at all. All the components
Oh.
had to get re-verified to make sure. I always say that wrong. It's not re-verified, it's just verified. Verified that they're actually going to work. My English is not well. So you have all those other stipulations. So you can't actually take a system and just make it an A2L system. You have to buy a brand new system. Everything has to be fitted for that.
Well, yeah, it makes sense. Like I said, I just started seeing those under counter ones, R290. I haven't actually had to work on them yet because I
Mhm.
don't think you're even supposed to like leave service ports on them or anything like that. You have to make sure they're sealed and everything.
Yeah.
Um, I've seen Chris Stevens on his videos, so I have knowledge of it just from watching him. But the ones that I found are still under warranty, so they get the company that sold it to them or brought it
Come
out
out and
to.
fix it.
Yeah, so I've already found like 3 evaps that are leaking. Need a little micro leaks and stuff. So haven't had a chance to work on them, but I've seen a couple of them.
Yeah, and that's the one thing that people get scared about. Like because what you're going to do is when you go to braze it off, right? That's why you use hoses that are no longer bigger than a foot. Okay.
Yeah,
And even your center hose isn't really that long, so everything is very in close quarters, because you know as well as I do, a liquid charge for a set of hoses, you could fit like 5 or 6 ounces. Well, shit, that's the whole charge plus some for something that small, right? So
yeah,
we have to be a little bit more precise when we're charging. One of the biggest things with A2Ls and any kind of flammable refrigerants, it's just you have to take a little bit more precaution, right? So they tell you that you should use nitrogen to just blow through the system. Just blow through the system and just blow anything out, because you're making sure you're basically picking up all that propane or A2L out of the system
yeah,
and totally. And they also tell you to do it outside. I don't know if everyone's wheeling out those refrigerators outside, but that's what they tell you to do. Um, and when you go to braze everything shut, once you're all set, you're supposed to pinch and then basically cut and then braze off that end.
yeah,
And it's only a little bit of refrigerant, so I mean, it's not horrible.
yeah. You
I've
just
only
have
done it
to.
once or twice.
Yeah, you just have to know the procedures and just take your time and make sure you do it the way they want you to do it. I don't know what's up with my comments. I can't see the chat in StreamYard like after like almost 20 minutes ago. So I have my iPad pulled up, and that was Ryan's question, was like, how do you seal it up after you're done working with it? So it's a pinching tool, pinch off tool.
That's probably where you'd use the hot block, right? Just to
Oh yeah,
just to ensure, right? Because you want to keep that shit cool, right? You don't want to run the risk of heating it up, because you don't want to trap any propane in there as well. That's the other thing,
sure.
right?
Yeah. And that's another thing. The hot, like, you have like all this stuff at your disposal, the hot block. I've had situations where I wish I would have known about it or remembered,
Mhm.
to use it, especially like on aluminum coils, because I had this real hard repair to do right where it was a Lennox unit that went out to a microchannel, aluminum, but it was copper to the aluminum coil.
Mhm.
I had a leak on the copper, and then I had a crack on the aluminum. So
Yeah.
I was talking to somebody, and they're like that they've done the same thing and they use hot block. And I'm like, oh man, I never thought about that. So because that obviously aluminum, different
Melting point.
melting point and all that from copper. And then when you make that joint, it's a lot that we have to deal with. You just have to kind of like, just know your resources or your tools at your disposal. And that's another question that I had actually was somebody asked on Instagram, what's the best way to charge an R290 system? Now you mentioned that the hoses and stuff, I know they have like a mini set now, right? For
Mhm.
the R290
I think
system specifically.
JB, I think, sells them. They almost look like small hydraulic hoses, but they're still color coded, still blue,
Yeah.
yellow, and red. They just look like hydraulic hoses, or almost like hoses that you'd see on a split system, like for a high pressure control or some shit. That's what that basically is what it looks like.
Yeah, with R290, you just have to be careful because it's like very critically charged. Like I said, I had one that was like around 3 ounces or 2.5.
Yeah,
And I was like, wow. I mean, it was a small cooler, but still. And then you have to, I have an R290 can, and they're little cans, and you need to
it's about
invert
yay
it.
tall.
Yeah, and you need to invert it, and they sell like a holder for it too to put on your scale because you gotta. Like I said, this one was in ounces, but most of the times you're gonna be putting in like grams
Hmm.
and measuring that out. So if you guys work on R290, there's gonna be a couple of little tools that you need to pick up here and there just to make your life easier. I've seen guys get away with kind of just making up their own thing and inverting it, putting a short hose and getting away with it. But they do make tools for that stuff now. And like I said, even Yellow Jacket, I think, just came out with a new analog set that has the scales for like newer refrigerants because we're going away from 410. We're like, it's crazy to say we're going away from 410,
I remember when
404.
came out. Nuts.
Yeah. And I actually had somebody that was like, because I was working on a 410 system and I had to condemn it. The coils were trashed.
Hmm.
It wasn't worth repairing like that. It needed a lot of repairs. And they were in the comments like, "What do you mean it's a 410 system? Like that should be like that's still new or something like that." And I'm like, "You do realize we've been using 410 for a long time now. Some of these units have been out here 20 years, 15 years, whatever it may be. It's not that new anymore. We're going to, newer things like very soon."
You're really not doing anything for my self confidence here. I know. I remember when it was called Puron instead of just regular refrigerant.
Oh yeah, Puron.
Because remember, I believe Carrier created 410A, so they had
Yeah.
their own name for it, and then yeah, fuck, I'm old. God damn it.
Well, how long have you been doing this? You said 20.
20, almost 21 years, I think. All right, so
Yeah,
I mean,
I've
good.
been doing this going on 16.
So I count my electronics. So originally it was weird. So I moved out of my house when I was real young. I was homeless for about 2 years. I put myself through college. I got a degree in electronical engineering, and I hated what I was doing. Like got the degree, and I was doing cell phone remanufacturing, and I was building graphic dimming panels for football stadiums and hospitals.
So
It was
you got into electrical engineering?
yeah,
That's what
and
that's what I had. Well, that's what I was going to college for before I switched over to HVAC.
so I got laid off from those jobs because I might have did it on purpose, and I just wanted to do something else. I was just bored, and I was going to become a trucker. I don't know why. I'm just like, yeah, I'm going to drive a big rig. I'm going to be like Hoffa. Who knows? And so I decided. I applied for a job. It said water treatment for industrial cooling towers and boilers, scientific needed. So a scientific degree, not required, but would be appreciated, or whatever the hell it said in there. I was like, I got an engineering degree. Does that matter? Like, and he's like, yeah, all right, yeah. So I started talking to guys like me, like doing commercial refrigeration, supermarkets and shit like that. So like I was testing water. So this was my
Mhm.
day. I'd fill up water. Yeah, it's hard water. All right, more chemical. And then I would just go all over the place. And I was driving all over the tri-state and in the lovely, lovely state of New Jersey. And I was working in the Newark, New Jersey Public Housing Authority. So in the wintertime, their basements become places of, they make them out of homes. And so you're in the boiler room and then you turn around and all of a sudden it's like, what are you doing in my house, boy? I'm getting the hell out of here. So I did that for a couple of years, and that's how I got interested. I started talking to guys like us, and I was like, "What do you do?" Well, we
Mhm.
make shit cold. I'm like, how does that work? So they explained, and I was like, cool. So I went to school for a semester of community college for HVAC, and after that semester, the instructor pulls me aside. He's like, "What are you doing here?" And I'm like real excited. I'm like, "I want to be a mechanic. You know, this is what I want to do." And so he's like, "You have a degree in electronic engineering." I'm like, "Yeah." He's like, 75% of this job from here on out is going to be mostly electrical and controls.
Mm-hmm.
He's like, you understand the theory. Just go get a freaking job. So I did. I quit that job. I ended up getting a job. I didn't even have tools. I got my first credit card. I went to Home Depot, maxed out a $2,000 credit card, and then took a cash advance on it so I can get a little bit of money so I can buy gauges and shit. Because
Yeah.
Home Depot does not sell gauges. So
Yeah.
so I bought the cheapest pair of gauges, and I just basically just worked my way up. And like I said, started in residential.
Oh, okay.
Worked on. I got to work on industrial compressors, air compressors for a little bit. That was kind of interesting. They got some cool stuff going on in there, and just bebopped around until I ended up just kind of sticking with supermarket. I like supermarket. It's a lot of hours. Can be a lot of hours.
Yeah.
But it never gets boring. It's always something different. With industrial, like big cold storage facilities, they might call you and say, "Hey, I got an evaporator iced up." I was like, "Dude, you got 60 more. I'll be there tomorrow." It's not really an emergency. You know what I mean?
Yeah.
Supermarket, if it breaks, you should have been there yesterday, and it shouldn't have broken.
Oh, yeah. Yeah, I have some guys that I know that do a supermarket and stuff, and hats off to those guys. Those are I feel like that's very hectic too. Dealing with supermarkets when that stuff goes down and whatnot. I'm in my own little niche, kitchen refrigeration. Pretty comfortable doing that. So, light commercial for me.
Nothing wrong with that. I mean, like, one of my favorite pastimes, and people make fun of me for this. I love cleaning condenser coils. I think that is one of the most relaxing things ever. I'll put music on, put my waterproof earbuds in there, and just clean coil because I'm not thinking about anything. I don't have to. It's just, I don't know. It's just something I like doing. De-icing cases, anyone else can keep that. I'll clean
Yeah.
condenser coils all day long though.
Yeah. The whole maintenance thing, I used to hate that actually. But like when I started, I really wanted to, I guess, do too much. I wanted to, work on the hardest equipment. I wanted to be challenged. I got bored really easy. So I hated doing maintenance because we did a lot of maintenance for like hospitals, of course, restaurants, because that's what we mostly do. But hospitals, so that meant like the refrigeration. That also meant like the hot side because our company does the cooking equipment too. My dad does that half of the company, but I had to help. When I started, I was just a helper for him. So I did fryers and grills and dishwashers, stuff like that. And even with the refrigeration stuff, because we got into that too. We had a guy that would, I guess we would subcontract for that until I can get my license and all that. But I don't know. I didn't like it when I started. I wanted to be out there like fixing shit. So now I do enjoy it a little bit more because it's the calming days. It's a little more relaxing, and I don't have to be like, or I mean, today I was in the hot weather, but most of the time it's usually you can schedule that stuff when you want to.
Yeah, 100%. So how long have you been doing this now then?
I'm going on 16 years.
Okay.
So like when I got out of school, I took a year off because I didn't know what I wanted to do after high school.
Yeah.
And I was going to go into electrical engineering. So that's what I started my college for. That's what I picked or whatever. Then my dad started his company, and I actually had a friend of mine that wanted to work with us. And he was like, my dad was like, I need a refrigeration guy. He doesn't want competition in the building with him, right? Because they would call him for the hot side and then call somebody else for the cooler or whatever.
Mm-hmm.
So I was like, okay. We looked, and not my college, because I went to, back then it was UTPA. I don't know what they call it now, UTRGV or something. It was a university here, but the community college had an HVAC program, which was great for me. I had a good experience there. A lot of hands-on because they did training boards. They had all these, and it was a variety because they did residential. We even did window units, even though I don't work on those. They had window units there that we worked on with walk-in boxes. I did have a industrial class, but of course we couldn't, hands on that. It was just like we would go to the chiller there at the school, and they would go over like the different parts and stuff. So I got a good experience out of it personally, and a lot of hands on.
See, it's funny. Like I work, obviously, advanced refrigeration, right? A lot of it's refrigeration, but I love. There's certain things I do actually like really working on. When I was up in Connecticut, you have, because it's a lot colder up there, right? You have these uh, burners on the main air handlers that could be 1,000,000 BTUs. So there's a linkage, there's a controller that just controls everything about this freaking burner, and like that kind of stuff. Or working on like a Munters unit. I don't know if
Hmm.
you're familiar with Munters.
Not really.
Okay, so what it is, it's a dehumidification unit. What they do is they actually run the air through desiccant. Desiccant is the stuff that's in filter dryers. It's also the
Yeah.
stuff that you find in brand new shoes. It says don't let your kids eat it.
Yeah.
I give them out for Halloween. I just collect them over the year, and then I just give them out for Halloween. But so they use desiccant in order to dry out the air. It actually, desiccant can get air, depends on like the capacity and stuff. You can actually get it down to about negative 88 degrees Fahrenheit dew point.
Yeah, I think the walk-ins at our hospital started putting that stuff in the boxes.
Yeah.
It's something on the ceiling.
Oh, really? That's interesting.
There's like a bracket, and it looks like it has that, like a bag of that stuff in there.
Get the hell out.
I never asked them what it was for because we didn't put them in there.
So I started using desiccant when I first was introduced to desiccant. I used to work on these desiccant air dryers. So you'll see a lot of factories, they'll use pneumatics to open and close doors, right? Because it's less energy than it is, I guess, for for like electric doors or whatever, right? And if you're a typical refrigerated air dryer, you can only get the dew point down to about 35 degrees, because once you get down below that, then the water is going to start to freeze. So the water's basically going to freeze within the unit. So they use desiccant. So if the pneumatic doors are in a place that, like a industrial cold storage facility where it has a freezer in there, they'll run their compressed air that operates all their doors through desiccant. So then what does that mean? So if we get the dew point of that air down to negative 88, that means it has to be negative 89 in order for moisture to actually start dropping out, right?
Mm-hmm.
It's the same concept. If you take a can of beer out of a fridge and you take it outside, what happens? Instantly with the can, starts to sweat. That's the dew point, right? But if you take that same can of beer and go into the freezer, it's not going to sweat, because now it's colder than what the dew point is of the can. Essentially, the can's warmer, so it's not going to sweat out.
Yeah. The chat is getting a little spicy over here. I don't know what they're talking about, racks and different things. Yeah, Jonathan is I can't post I can't pin the comments because my StreamYard's not working anymore. But Jonathan's one of those guys. He works in the big supermarkets like Walmart.
Mm-hmm.
So he posted racks all day. He works here in the valley too, because he's seen me on the roofs as well, because he works at, or I work at the malls next to where he's at and stuff. So they're talking about racks and other kind of racks in the chat. I need to get to the actual questions.
Boobs.
Someone asked.
Boobs.
Yeah, someone asked about suction line dryers.
What about?
Let's see. Oh, I guess he's had disagreements with technicians on suction line dryers. Do they get pulled and replaced after 7 to 14 days, or do you pull them and leave them out?
That is it's going to be a customer spec typically, right? So they're either going to tell you to leave them in or take them out. A lot of times you don't know whether they left the stuff in there or out. So you have to somehow prove that they're in there. So one of the things that we do to check that sometimes, because usually the filter dryer, the caps are on the end there. And just so happens if you do take out the Schrader, so if you have to pump down the rack in order to do this, because we can't lose any refrigerant, but you pump down the rack and then basically take out the Schrader and shove a piece of Silphos in there. If the Silphos stops within, an inch, then there's a filter dryer in there. Otherwise, take it out. And then on some racks, like Hill Phoenix Advancer CO2 racks, the transcritical boosters, they actually don't have liquid filter dryers. They actually have a liquid strainer. And
Oh,
then
okay.
actually, you know, the filter that you would you know, if you needed to dry the shit out, if you needed to dry the refrigerant out, because unfortunately with CO2, if you have moisture within the system, it'll actually create what's called carbonic acid, and it'll start eating out the inside of the pipe.
Oh, no way.
So in that instance, you would have to put, like, if you were trying to take the moisture out, you'd have to put a liquid filter dryer in the suction, just because Advancer does not put liquid core dryers
Yeah,
in, you know, on their liquid line. They just have a strainer. I don't know why.
gotcha. Yeah. Yeah, I was gonna say, because he asked me that. I think that was a YouTube question, but I don't know. We don't typically deal with too much of that. I thought you had to take them out, but I think I've seen them left in the system too. The suction.
It
Uh,
depends. It depends on the customer. Like, you know, certain customers are like, after you do a remodel or a startup, you make sure that they're in
oh,
there after X amount of time. After you did all the oil changes, you know, you take them out
yeah,
after X, because they want to make sure you're catching any of that copper, right? So let's just say someone doesn't deburr stuff. There's hundreds and hundreds of feet of piping, right?
yeah.
So to think you're not going to catch a speck of copper throughout there is it's just going to happen. And what can happen is you have that copper coming back through the suction, could, you know, come into contact with the windings. It could cut into the insulation. So all of a sudden, and then the compressor's garbage. So having that strainer there in the, you know, in the ass end is gonna help you a little bit.
Man, that some of that, like, because I'm on TikTok too. I post there and stuff, and I see a lot of other guys that do this. And there's a guy. I'm pretty sure he does supermarket as well. Like, I don't know how some of this stuff gets done or what, but so speaking of, stuff in the lines and systems,
Yeah.
whatever, they had this. I forgot what kind of valve it is. It's some sort of just mechanical valve
Mm-hmm.
that they had to replace several times, and that it would work, and then they would get called back for it and replace it again, or something like that. They had something going on in that line set, so one of them finally took it apart or caught it when it was happening. Like, I can't remember what it was exactly. They opened it up, and there was a small coupling. It would look like a reducer that was trapped in the line set, and it had been floating around. And every now and then it would get jammed, and they would think it was a valve or something. And I'm like, I don't know how that stuff happens, but it happens.
We just recently on someone's job that was having a problem, a rag, a rag,
A literal rag.
a rag, or you get pipe plugs, right? When you're doing how many thousands of feet of piping, and you're just putting
Hmm.
the shit together real quick. Because usually what we do is we hang the hangers, and then down at the bottom, you basically take that 20-foot stick of, you know, let's just say inch and one, throw the 3-piece, you know, of you know, Armaflex up there, and throw it up on the hanger, get it up there, whatever. And just saying, sometimes, and sometimes also the copper piping actually has a pipe thing stuck in further. So it's
Mm.
fucked up, because you'll have this pressure drop, and you're like, why is my suction pressure at 140 pounds? That shouldn't be that. The other problem with some of the newer energy efficient cases, they have, you know, because we're all running subcoolers or running CO2, so very high BTU per pound exchange. So the liquid line, the suction line will be the same. And that's always a fun thing, because
Oh,
they're labeled at the top, like right at the top of
yeah.
the drop or whatever. It says liquid and suction, but hey, was it Friday when he put the stickers on, or was it a Monday, or maybe it was a Wednesday? We're not going to find out.
Yeah, I think the weirdest thing I found was somebody didn't take off the plugs off the compressors, I guess.
Hmm.
And I've opened them up and found those plugging up the line set there. So I don't know. Shit happens.
Well, so even on the newer stuff, so the bits are subcritical compressors. They have this piece in here. All right, it's a strainer, and it goes in the suction. Now, if anyone's ever seen the smaller Copeland compressors, it looks like it's called a K body, right? Where the valves are right on the top of the head of the compressor. In there, that's not a suction gas cooled compressor, because any of that suction gas that's supposed to cool the compressor
Mhm.
is basically going right to the head. So those
Oh,
compressors, K bodies, either have to have the copper water jacketing running around them, or it has to have a fan blowing across the you know, the back end side. That's why there's so much cast iron on those K bodies, to transfer that motor heat, right? So this little piece in these subcritical bits or compressors, actually what it'll do is it diverts the flow in whatever way that you put it in. So if you see, this is where the service valve would attach, right?
Yeah.
So this sits around the compressor. So on this brand new rack, I was doing training with these guys, and we went out there, and I just went over this. We were just talking about it, and sure as shit, 2 of the compressors were running nice and cold, and they were running I don't know, probably. I mean, they were sweating on the back. They were running nice beer can cold. Not that that's a term that you should be measuring off of, but they were cold. And then the other 2 compressors were not so cold, but they were all running. And sure as shit, we just finished talking about this, and they're like, these 2 compressors are going off. Like he's like, we've had problems with these 2 compressors, and I saw, and I was like, this thing's in backwards. So it wasn't actually diverting the suction gas across the windings first before it went up to the head. It was going right up to the head. And, you know, on these smaller, you know, semi-hermetic compressors, they usually always have a motor protector module, right? Measuring the winding temperature. So if the winding temperature gets too hot, it's going to open up to make sure it doesn't grenade. Well, that's exactly what was happening. They couldn't figure out why. They were like, well, we have good superheat coming the ass end of the compressor, but because this little piece was installed improperly on 2 compressors, they had continual failures.
The stuff you find in or out there in the wild. We have HVAC guide in here. Like I said, I can't pin the comments. I don't know what happened to my StreamYard.
It stopped.
But it's not working for you either?
No, because I was like, either everyone's just listening to me talk, or everyone left because I was talking.
I know. I looked up and I'm like, is everybody gone? I was like, and I pulled up my iPad and I'm like, okay, no, they're still going. Freaked out for a second. HVAC guide is like, I mostly do residential. I'm a little lost. Refrigeration, I mean, that's what I love about it, right? There's like so many different avenues and equipment. So you've had like you said, you started in residential, and then what did you mostly do? Was it supermarket? Is that expertise?
Yeah, probably. So like I said, I went from residential, and then after residential, I went to commercial, and at that point my life was getting really, really busy. So I wanted to do something else. So I actually did appliance work for about a year. Ran to a guy at a supply house about a year and a half later. He said he was looking for a refrigeration mechanic to work on those air dryers that I was telling you about. And I got to see some really cool stuff. That, you know, the industrial air compressors are amazing. They're, you know, they 1,000 horsepower freaking motor. You know, and it's really cool. Like on the reciprocating air compressors, they actually have valves, discharge and suction valves on both sides. So there's never a wasted stroke. So like, you know, when you push up, you now push that gas out, and you come out, and then you pull the suction gas back out. No, this has valves on either side. So there's never a wasted stroke. So no matter what, it's always compressing in either direction. This piston, when I tell you, how tall are you? Almost 6 foot?
Yeah, like right under like 5'10", 5'11".
You and I could hold hands, and we might be able to reach around that cylinder.
Man,
it's freaking ridiculous. They actually had a gantry hoist on the inside. So I did that for a little bit. And I liked the company I was working for, but they kept telling me, be glad you have a job. You know, it was around the time of a bad recession. And I was like, man, I'm a reefer tech first and foremost. I get a job tomorrow. I just enjoy working here. So they said that. And after they gave me a pay cut, because they gave everyone a pay cut, I then was like, screw you. And I ended up, I was like, because I already knew refrigeration, and now I knew the big stuff. Now I knew industrial motors and industrial VFD driven motors and all this other shit. So I made myself smarter by doing something that I didn't think I was going to enjoy. And so then I went to industrial refrigeration. Did that for 5 years. Some family stuff happened. I ended up moving up to Connecticut for about 5 years, and that's when I got that job up there, as a service tech, and then basically became an EMS tech. And 5.5 years later, I decided to move to Texas, and I've been here almost 8 years now, I think.
So, now you do trainings, right, with Cool Size. How's that going?
Awesome. We did probably 270 people between in-person and online training. As far as people going from the next level that they're currently at, I am working very diligently at making all these different trainings, advanced CO2, intro to CO2, advanced EMS, and then I'm also making some more specific stuff. Because like with supermarkets, sometimes you might have this oddball supermarket that likes this one type of system, right? So that's what they want to do. The programming's that way. So I also make specific programs for that piece of equipment. So what I do is I take pictures of everything that I took, and then get the program. I'll put the program on my controller that I have sitting right here, link it up to the computer. I'll take a screenshot, and then I'll have the screens that's actually here, right? Then once I do that, I'll take the electrical drawings, because all the inputs and outputs that are being controlled by this guy have to control a schematic. So basically you look at, I show you what the program is, what the program does, what the set points are, and then that segues into, well, where the hell do I find where this thing is? And then it shows you that. So I do a lot of that specific training. We're actually Coolsys in the midst of where we purchased our first CO2 transcritical trainer that's actually going to be in Houston. We're going to be doing our first in-person classes officially this training year. And I'm pretty sure we might be getting another transcritical trainer out for California as well. We're doing a Houston expansion project where we're expanding the training center and making it bigger than what it was. Our C&I side, our commercial industrial side, there's 7 levels. The only place you could before do levels 6A and B was in California. So now I got to fly cats all the way from LaGuardia all the way out to California. So instead of doing that, I was like, well, why don't I just build the equipment there, and it'll save my department a crap ton of money, because now I don't have to fly these guys, all the way across the freaking nation, right? So we did that. I built out a compressor teardown table so I can start doing like compressor teardown classes. So you can actually see, they'll bring back compressors, or I'll work with the local supply houses, because usually the compressors that you take back there will sit for a couple weeks, right, before they load them all on truck and then ship them out. So, and they don't give a shit if they get taken apart. Like if you have the availability and you have a semi-hermetic compressor, take that thing apart and find out what the hell happened inside. It will prevent you from having a failure in the future. I promise you that. And you talk to Bitzer, Carlisle, Copeland, I don't give a shit who you talk to. They're going to tell you, we want you to take it apart. I want you to know why it did it, because I don't want you to have to coming back to me and saying, can I have another compressor? This one grenaded too. You know what I mean?
Yeah. Because, I started saving some. I want to take some apart too and cut into them. But most of the times when you're dealing with the compressors and stuff, there's either a reason, bypassed safety or something that happened to that compressor, or it's not the compressor at all, and you're swapping out good compressors for good compressors basically. And it was something else, because I'll be honest, when I started, there was a couple times where, well, actually a couple times wasn't my fault. I don't know why, but I got a defective compressor. That actually happened to me twice over my career, where like it would one of them would just over amp on start, like nothing was wrong with it. Now I don't know the science behind it or anything like that, but and there was another one that wouldn't start, or it did something similar. It was when I started, so I can't remember. But other than that, you have to deal with that. Returning the compressor, and then you got to tell them, well, so this and this happened, or what, or and more times than not, it's usually user error or something of that nature. So yeah, if you can, I watch a lot of guys on YouTube that take them apart and stuff like that. So it's always good to see the internals, because us, as service techs, we're swapping out parts, and sometimes we don't know how something works, or the internals and all that kind of stuff. And then once you start looking into it, you get a better understanding of what it's supposed to do, how it affects this or that, or when it overheats, what exactly happens to the compressor. Which more times than not, like a lot of things that, or a lot of the ones that I see that die, the high pressure control for some reason was left bypassed. Either they left it like that, or they meant to come back, or something of that nature. Just I see it. You already know that's the issue. But yeah, like I said, visual. I'm a visual learner. I think a lot of us are, and being able to see that. I think okay. Jonathan was asking if it's only Colsies that you do this through, or does anybody else have access to your trainings?
No, I mean, no, unfortunately not. You'd have to be an employee for Coolsys.
Okay.
Can listen to Advanced Refrigeration podcast. There's some good stuff on there.
Yeah, be sure to check him out on his podcast. You're on YouTube, you're on podcast, you're on Instagram. So
yeah, and I started trying to put some of the podcast up on YouTube in Spanish subtitles.
oh yeah, I saw that.
Yeah, a lot of the cats that I work with, I work with a lot of guys from Florida, I work with a lot of guys in in Texas, obviously, in Arizona, and that, and it's like I said, I'm just trying to get people to just get the information out there, right? The reason why we started the podcast, I don't sleep well usually, and I think it was like 3:30 in the morning. I went down a YouTube hole, and I was just like, "Oh my god, someone's gonna fucking die." And so I texted Kevin at like I think I waited till 4 because he usually gets up, goes to the gym in the morning, and I was like, "Dude, we need to start a podcast." He's like, "Why?" I was like, "Because someone's gonna die." He's like, I was like, "But someone's gonna die." Like there's so much bad information out there. Like, I mean, that's why I'm glad, the people that we usually deal with on the regular, like all those cats are good mechanics. They know what they're doing. They are being safe in what they're doing. And I'm appreciative of that because I mean, you only get one body, right? So you got to be safe the whole time. Like I don't know what it is with refrigerant burns, but everyone always wants to be a hero when that hose starts to spraying. I don't care
Just
for the
just let it
1,000th
go.
time. Let it
Let it
go.
go.
It's not worth it,
Yeah,
man.
I had to mention that a couple of times because I'm like I guess I guess like you want to be the hero or whatever, like just it's not worth it. Always I try to always wear gloves. I try to have as many, I have the ball valve adapters on my hoses or something where I can shut off like on the high side because you get a lot of blowback from
Mhm.
that hose being so long. Just whatever it is, try to limit the refrigerant coming out. But then if it comes out, yeah, I mean it's not worth it.
So you were talking about bad compressors before, and I need to tell you this story because this is one of my favorites. So I was in the
Okay.
middle in the middle of Pennsylvania, and I was at I think it was this slaughter transport. So you get all the cows on the hooks, in this room, and then just divvied up to the local butchers or whatever. And I was there to replace the 3D, brand new 3D right out the box. So I get up on the roof, I put the compressor in, crane came, took the other one back downstairs, light it off, and within about I think 5 minutes or maybe less, it went off an internal. The only reason why an internal goes off is for usually two reasons: higher amperage, high temperature, right? Because if you took a 3D and you took the pecker head off of with the electrical connector, there's a whole bunch of 5/16 bolts underneath. There's like 16 of them. If you take them up, you pull that up, you'll see where the three wires go on the bottom of the terminal block, right where the pecker head covers it. And then you also underneath there is an actual three-phase overload that is bolted with two machine screws directly on the stator. So it's actually measuring the temperature, to make sure it's not overheating, right? So if you have
Yeah.
a compressor that's blown by, that's why basically it overheats because all that discharge gas is right going through. I had good superheat. I didn't have oil failures. I had beautiful freaking everything. Everything was working just fantastic. And I call my boss at that point, real cool guy. But I was like, I can't figure this out. He's like, what do you mean? You're in the middle of nowhere. Just figure it out. I'll get someone else that really really can do it then. I was like, so I hung up the phone. I was like, you know what? I'm just going to step away. So when I stepped away, I had the model number of the compressor. I started looking up the information because I wanted to see exactly what amperage that overload came up by, right? Because it doesn't say when it trips, right? It says max, and that's it. It's not going to trip right at max though. So if the amperage 48 amps, it's not going to trip right at 48 amps, right? So there's a 230 volt compressor. So you'd expect the amperage to be a lot higher for a 3D. We're talking like 15 horse probably, right? And I'm reading, and I'm dyslexic, and I read really stupid, so I have to use actually an index card when I read, because otherwise, like, as I'm reading, I will totally fuck up a story. So example, if I'm reading my kids a story about Dick and Jane riding an elephant and then going eating lunch, I now have fucked up that story so bad that now Dick and Jane are eating the elephant, and now my kids can't go to sleep. So yeah, so I have to use an index card. So anyway, so I'm reading through this book, but I started going from bottom up, and that's how the compressors are labeled, but they start at the higher voltage down below, and then they go to lower voltage. So the thing was tripping out at 21 amps, even though the RLA was 43. And I'm looking, and I'm like, 575 volt overload. That trips at 21.9. No fucking way. So I go back out to the compressor, and I was like, no, it definitely said 230. I checked it when I was at the supply house. And I'm like, maybe the overload's wrong or something. So I literally, I pumped the compressor down, got it, no refrigerant in the compressor, busted open those 5/16 screws, put it on its side, took the overload out, went back downstairs to the truck. I'm reading through, and sure as shit, they put a 575 volt overload in a 230 volt compressor, because it ran. And it ran.
Yeah, I was gonna say the voltage was right on the compressor, but
yes,
the overload.
yes.
Okay.
So the overload was rated for 575. So the higher the voltage, the lower the amperage, right? So you would put a lower amperage limit in there. And that's essentially what happened. It was supposed to be running an RLA of 43, but was failing at 21.9. And yeah, that was one that I'm really, really proud of. Like that, I thought that was the coolest freaking thing. And I was young too. You know what I mean? I was still living in PA, and that was 12 years ago.
Yeah, man. Like, just, figuring out stuff, especially when you're new. It's a great feeling. And it just goes back to, like, paying attention to all the details. And, that's good that you found that, because that's a hard one to find. And you sometimes you have those head scratchers, and then you need to take a minute, like you said, kind of calm down a little bit, and you're like, what's really causing this? But man, I've never heard of that.
Well, and sometimes it's luck too, man. So I was working with a kid.
Yeah, you catch something.
Yeah, and so, like, I tell people, like, when they walk into a motor room, like, get used to what it smells like, get used to, like, what it sounds like,
The
and
sounds and everything.
yeah, and like, just look for anomalies, right? Because that's what I do. I look for something that's just way off the wall, right? And so he's working on this hot gas system, and I guess he's had like 4 other people there, and I came over there to help figure it out. And I noticed right away that the liquid line ball or solenoid valve was rebuilt recently. Okay, this is a 2-pipe hot gas system, but this one particular valve, this liquid line solenoid, is a bi-flow valve. Actually, hold on. So if you actually open up one, this is what a typical Sporlan plunger assembly looks like, right? It has that one hole.
Mm-hmm.
This is one from the same exact valve, but you see how it has 2 holes there?
Oh, okay, yeah.
There's a little ball in there. So you see there's a metal piece stuck on the top here. So that check, it actually can make the valve go. You see, flow can actually go in either direction. All right. As long as I've been doing this, I know for a fact that no one ever has the innards for a bi-flow check valve. You'll actually see it. It'll say CV instead of just V in the beginning. And they've never had that in stock. I always have to wait for it for some reason. So the balance of probability was someone probably messed up and put the wrong guts in, and it just didn't have the right flow. So this kid's been working on this for 4 fucking days. So it's like, grab this Cooper, go down there, and put it on the suction line. And he's like, it's not going to fucking work. It's not going to work. It's not worked 4 days. I'm like, I just want to see what you get. So he's down there. I was like, so what's happening? I had my because I usually carry a 6-in-1, my meter, a reefer wrench, and a little adjustable. So I went on the back end inside of the solenoid, and because there's a manual stem on there. I drove the manual stem in. He's like, see, it's not getting hot. What? It's getting hot. It's getting hot. Well, what did you do? What did you do? I was like, and all I said was, I was like, 28 seconds and get your ass up here. And I hung up. He's like, what the hell is that supposed to mean? 28 seconds. I was like, that's how long I've been here. Oh, he felt so bad. But like that, but is because what I did first, right? I looked around the motor room to see if you saw any anomalies, right? Because sometimes you'll catch that thing. That's why I'm a true believer in keeping the equipment clean. It makes it easier to find leaks. Dude, I will get down and I will start, literally spraying all the compressors down, all the controls down with green clean. Because then you can, one, it gives your customer this warm and fuzzy that you actually did something, and you did.
Oh yeah.
You're basically helping yourself find leaks for later. And it just makes it easier when you're going and working on stuff.
Yeah, that's what I try to tell. Like, my brother, he's younger than I am, and any guys that I work with, I'm like, clean. Like we mostly do rooftop units, walk-ins. Clean around it, wipe stuff down, wipe the carefully, wipe the labels on the compressors and everything around the unit, just so it's easier, the next time. And then, like you said, you can see if there's a leak. You don't know if it's old oil or new oil, stuff like that. So definitely try to do that, even if we're not doing maintenance or anything. Just try to wipe it down. If we are doing maintenance, then for sure take the time. Take all the panels off, clean everything, even if it's stuff that the customer doesn't see, because for residential, I guess it makes more sense because the customer will come out and look at the unit, right? And if it doesn't look clean to them or it doesn't look any different to them, they're gonna say that you didn't do anything, or whatever comes up. As far as like commercial or what I do, I've invited the managers up. I think they've only taken me up on it like twice, but you never know. You never know if somebody's gonna go after you. What I always tell people is it might not be the customer. They might get a second opinion, or even a coworker. If you're working at a big company, if you do something wrong, you leave something dirty, you leave trash up there, after doing, a part change out or a compressor change out, whatever, take the compressor down. I've seen so many places that have like a graveyard of compressors on the roof.
I never understood that. I never.
And yeah, the compressors, the boxes, I'm like, man, we have to end up cleaning up after them. And you never know, the customer might go up there, another company or another tech at your work might be like, hey, this so and so did this. So and so is not a good tech, or whatever. Like, just always keep that in mind. Like, somebody's going to come after you. Even us, like, we're pretty confident with our work. We try to do the best to our ability or whatever. We have budgets and NTEs. We got to deal with all that stuff. But the one thing is we take pride in our work, and clean up after ourselves. All that stuff my dad kind of implemented on us, even though he doesn't do HVAC. It's like, it's across the board, stuff like that. And, we would think, oh, we're the only ones working here, or whatever, they always tell you you're the only one we'll call, or this and that. Second opinions happen, or bids happen, and somebody else will go out there and they'll be like, they didn't do this, or they left this up there. They'll tell on you real quick.
Well, yeah, they want to make themselves look good,
Yeah.
Man, I didn't realize it's been an hour
Just
40. I'm so sorry. I feel bad
No,
now.
it's fine. Don't worry about it. Just real quick, HVAC boss Angel is in the chat. He's been waving and waving,
Oh, sorry.
trying to get our attention. But Angel just showed up there. I don't know. The StreamYard's not working, so I'm trying to read it off my iPad. Yeah, now he's like, Adrian doesn't even care. I'm right here. I'm reading the chat. There's some other stuff going on in the chat too. Jennifer was like, "Oh, good. Brett can't see what I'm saying now."
No, because I'm not saying I'm not like I don't want to keep looking down. I'm checking out Tinder while I'm on a podcast. No, I was legitimately trying to look to see what was going on in the chat, but I'm getting old, so
No, it's just like guys checking in.
what's up, Ben?
Oh yeah, Ben Pohl is in the house.
Ben Poole.
Angel is he's like, Angel's taking over the chat.
I'm sorry, I kept talking. I feel like I haven't answered anyone's questions. I just keep rambling.
Well, they're talking about like racks, and I don't know. Jennifer was chatting with somebody else right now. So you deal with a lot of CO2, right?
Mm-hmm.
How you have to be really well trained on CO2.
So, here's the funny thing. So CO2, for the most part, It depends on what type of system. You got a couple different types of systems. You have what's referred to as a cascade liquid overfeed system. So what will happen is they'll run like an HFO or an HFC. They'll run a saturated suction of approximately -20 or -27. I'm sorry, -27. So by maintaining a -27 degree saturated suction, I can get my CO2 to basically be -20. And it just goes, there's these heat exchangers on top of this big vessel, what I refer to as it's almost like a thermal siphon. So it's a liquid vapor separator. So these heat exchangers stay on top. So where's the vapor going to go? If you have vapor CO2, where's it going to go? It's going to go up, right? It's lighter than the liquid CO2, right? So what happens is it goes into the heat exchanger, gets refrigerated by the HFC or HFO, then brings the physical temperature down of that CO2 down to -22 on these on our -20. So on these cases, though, there's no expansion valves, there's no pulse width valves, there's no bipolar valves, there's no mechanical valves. The only thing that's there is a solenoid valve. They're actually using the CO2 as almost like a glycol, where they're running it out. And because these coils are flooded, so typically, as well as I do, most evaporators have a 10-degree TD, right? So if we wanted to try to maintain, -10, we'd have to maintain -20. No, because that's only at a 3 to 5 degree superheat. If you get that superheat where you have a flooded evaporator, the heat exchange is amazing. And basically you could actually, float your suction pressure up, and that's essentially what we're doing. And there's no compressor. So you don't give a shit if you don't boil off all the refrigerant, because it goes back to this liquid vapor separator anyway, and then just gets reconstituted. It's a centrifugal pump. I think it's called a Grumfoss. They have a shop out in Houston that sells their self-contained CO2 pumps. That's pressure typically on that system runs usually at 210 suction vessel pressure, and then the pump usually knocks it up about 35, 45 pounds. So that's one flavor of CO2. Then we have cascade, direct cascade. So you'll have the same type of setup, but instead of the compressors operating at a negative pressure, they're just trying to bring the CO2 saturated condensing temperature down to 25 degrees. So basically, they have a CO2 compressor on this one. On the first system that I described, no CO2 compressor. That's just pumps, just centrifugal pumps. This guy has HFC compressors. So now they're running a lower compression ratio because you're only trying to maintain 16 degrees saturated rather than -20, right? So that 16 degree saturated will actually give you about a 25 degree liquid CO2 temperature, which goes to a regular conventional vessel, which that means your vessel is going to be at around 450 psi. Your suction on your CO2 is going to be approximately about 210, and those actually have CO2 compressors. So you have to make sure you're controlling the superheat. So this is not like a pump liquid system. You're driving that CO2 out there with the compressor. They usually run it through a desuperheater before it goes to these plate-to-plate heat exchangers, because brazed plate heat exchangers do not like really, really high temperatures. They don't like temperature fluctuation. So they try to usually maintain about 95 degrees going to those heat exchangers. It's not too much. That condenser is basically now taking the liquid refrigerant, using that energy to basically condense the vapor CO2 into a liquid, goes in the receiver, goes out normal way, comes back via the compressors. But like I said, on those cases, we actually have something that's actually controlling the superheat. So we have a controller that's basically turning the valve on and off, or whatever, based off of the superheat in the discharge air. And then lastly,
what kind of pressures do you see on those?
So on the vessel, you'll see about 450, and then you'll see about 210 on the suction. Now, CO2 has a very, very high PT relationship, right? So at 87 degrees is 1059 psi. So imagine, if you will. So this is what's messed up about CO2. So on all these systems that are CO2, that any CO2 is going in the store, they have a liquid and suction ball valve like you would any other time, but they have a check valve in parallel with it. And the reason for that is if you were to close it off and you didn't make sure that the refrigerant you know, you didn't get rid of the liquid first, where it like just rapidly expanded, and it gets up to X temperature. Imagine that pressure increase, and then boom, we don't want boom. So we have the check valve in there that basically, if the pressure of the coil is higher than what the rack is, it'll go around the check valve and back up. So then it never will go boom. No boom.
Oh, okay.
So that's the reason why we have them. So those valves being on those around the liquid lines and suction lines are very, very crucial as far as safety. Because imagine, like, if you have a coil that's at negative 20 degrees, right? That's a 210 psi pressure, right? Let's just say I closed off both those valves and then I hit it with some 87 degree water. Can you imagine how fast that expanded, Will?
Oh, man. Yeah.
Oh, yeah. So once again, it's there for safety. CO2, the more advanced you get, so like the first liquid pump overfeed, very simplistic system. You're not really worried about superheats and all that other shit. You don't have CO2 compressors. You don't have to worry about oil separation, anything like that. Then you get into cascade, then you have CO2 compressors. Now you have these electronic case controllers. Now we're going to talk about the last style of CO2, transcritical booster. So if anyone here has worked on a Carlisle compound compressor, and if you don't know what that is, Adrian, it's basically a compressor that has 3 heads. First 2 heads on the left-hand side, suction is attached to both of them, takes that gas, compresses that gas. That gas then goes out and into the ass end of the compressor. That pressure will be anywhere from 68 to about 78 pounds. That'll be your inner stage pressure. You also have to have some liquid injection and vapor injection there. The reason why you need that is because, as you know, most of these compressors can't take more than 65 degrees entering the ass end of the compressor, right? That's the limit for Copeland. Otherwise, it's going to go boom. No boom bad. So basically, we cool down that ass end of the compressor by the liquid injection and the vapor injection. Then it goes back through the compressor and gets sucked up through that last head. So we're basically doing 2 separate compression ratios at the same time. We're going from 10 pounds to 68 pounds, and then sucking in at 68 pounds and getting it up to, let's just say, 250 pounds for like a 448, 449 system. So it gives you 2 lesses of a compression ratio. So you're not consuming so much energy. A transcritical booster system works exactly like that. But instead of having all that shit go happen in 1 compressor, we're making all that shit happen in 2 compressors. So what's going to happen is you have to start the medium temp first. So the medium temp drives into what's called a gas cooler. The reason why it's called a gas cooler and not a condenser, because once CO2 reaches its critical point, the supercritical point, which is above 87 degrees saturated, there is no pressure temperature relationship that they really know. They kind of guess at it. They kind of Dr. Seuss it. They're like, it could be this, could be this. And it turns into this, what's called a superfluid. It looks like a foggy, misty, messy type thing. So, I mean, that's the weird thing about, CO2, right? You have basically 4 states of matter, right? You got this weird super fluid, you have liquid, you have vapor, and then you also have dry ice, right? And dry ice actually sublimates. It doesn't melt first. It does, but it turns directly into vapor.
Yeah.
Anyway, you take this suction gas, drive it through this compressor, go to the gas cooler. Out of the gas cooler, it goes into what's called an HPV. No, it's not the human papillomavirus. So I know some of you guys probably already have it, but no, that's not the HPV I'm talking about. It actually controls. What it does is actually has a ambient temperature sensor, but it also has a temperature sensor on the drop leg of the gas cooler. It also has a pressure transducer, and once it hits that super critical point, it literally, the controller itself, it's trying to maintain a certain subcooling right there. But the problem is with that, let's just say the saturated condensing temperature at that point is 70 degrees. So it's running below supercritical, but it's still running fairly high pressure, probably in 1,100 pounds. CO2 system can be as high as 1,700 pounds, 1,700 psi, which is that's the only real freaky thing. So it's the high pressure that kind of scares people, right? And also the weird funky stuff as far as the HPV. Because here's the thing. So if we're running a 70 degree saturated and it's trying to maintain 5 degrees of subcooling, then theoretically the line should be about 65 degrees, right? Would you agree with that math?
Okay, yeah.
Okay. But here's the messed up thing. The HPV, when it opens up, it basically drops that pressure down to a lower pressure. So even though you have 65 degrees, now your saturated suction of the CO2 is like down to 39. So like theoretically, you're like, well, Didn't all that disappear and just turn to vapor? Well, here's the thing: when you're running subcritical, that HPV, that transcritical rack, will basically create probably 70% liquid, and the rest of that vapor is basically boiled off. The reason why the next place that refrigerant goes, the flash tank, why it's called a flash tank, is because there's constantly flashing off of refrigerant happening because you're pulling off the vapor. The way I can explain a flash tank, so the theory kind of makes sense, is if you have ever recovered refrigerant from a rooftop unit, and you had this magic recovery cylinder where for some reason the red was the vapor and the blue was the liquid. They were swapped. The colors were right, but as far as what it said on the cylinder, as far as which one was wrong. So if you've ever like put that refrigerant back into a system and you accidentally hooked up onto the vapor, what happens when you do that? The bottom of the tank starts frosting up, right?
Oh, yeah.
Dropping the pressure, you're dropping the saturated, so you're inadvertently actually creating that liquid is starting to flash off because you're pulling the vapor and dropping that pressure down. Same thing what happens when you fucking grill, right? You're grilling outside and the LP cylinder starts getting all frosty because you've been grilling for 6 hours. You're basically pulling that vapor off that propane. You're boiling off that the propane that's in there, and that's essentially what a flash tank is doing. So besides the high pressure, the whole supercritical fluid crap, and how the flash tank basically acts like a oversized recovery cylinder when you're pulling vapor off the top. Those are the only three differences. Everything else is just straight up. You're still doing direct expansion. You're still trying to control superheat. There are some little nuances, like most Copeland compressors, right? They'll tell you the minimal superheat you want on an HFC or HFO compressor is 20 degrees. No lower than 20 degrees of superheat, but no higher than 65 degrees Fahrenheit, which totally makes sense for all you air conditioned cats out there, because basically you're maintaining what 40 degrees saturated, right? 40 plus 20 equals 60. So you're still under the 65 degree mark. And then the only time you might not is when you have a stupid load, like you just got the system up and running from being broke. Where's it going to run? Around 45 degrees saturated. Still going to have 65, still going to cool the shit out of the compressor, right? So besides those three other things, man, like CO2 it's really the same as an HFC, like as far as like the normal operation. Like I said, gas cooler, super fluid, and the whole flash tank thing, because that literally took me an hour to wrap my brain around, because I'm like, it doesn't make sense. The numbers, like I'm like, how does it not do that?
Yeah, and it's something new, like everybody are new to some people, and same thing with the propane stuff, the R290. They're like, oh, it's gonna blow up, and CO2, they're worried about the pressures, but I mean, we're going in that direction whether we like it or not.
Dude, you guys are gonna start seeing in the light commercial stuff.
I was gonna say, you guys have it in supermarket only right now, right?
Yeah,
And
supermarket, industrial, like industrial style facilities, right?
So then eventually we'll see it trickle down.
Yeah, I mean, as long as but that's the thing. So if they can get around, the equipment's rather expensive, like just because like the gas cooler piping from the discharge of the high stage compressor going into the gas cooler, all that has to usually be either stainless steel,
Okay.
and it has to be TIG welded, or it has to be what's called as I'm dyslexic, so I always screw this up. HXP. Yeah, extreme high pressure. It's a Mueller product. It's basically copper tubing, but it's made with ironclad. So it's not just straight copper. It basically gives it a better burst rating to handle those excessive pressures. I'd rather see it stainless, because we all know that copper does eventually get a little brittle, and from vibration and whatever else have you. So like from the discharge line, honestly, I'd rather have stainless steel all the way through. I get it, it's a cost.
Yeah. I mean, copper, I think there's several things that can go wrong with copper, but I guess we'll see. Jonathan here heard that Target has CO2 single refrigeration systems. Jonathan, I think he's the one that does Walmart's.
It could. I mean, I know they have some small CO2 like self-contained type stuff.
Oh, okay.
Maybe that's what he's talking about. Like, because I know a lot of different big box stores are pushing the whole we're going natural. That's
Yeah,
just
that's
gonna
where
come.
you're gonna that's where you're gonna see it. Um, those stores, and like I said, I don't remember what it was, but Coca-Cola and Pepsi had some stuff too, where it wasn't like at the time I only was familiar with 134A and 404. And then I started seeing them, buy new equipment, and it was something else, and I was like, whoa. Um, and that's funny, right? We're phasing out a lot of stuff now because when I started, I didn't see R12 or I saw very little R22, but 410 was new, 404 was relatively new, and now all that stuff's getting replaced. Oh, HVAC boss, can we talk about what do you want to talk about? Oh, the HVAC Tactical Awards 2024. Um, Angel, you need to come back on the show and we can talk about anything you want. And tell Tito to come on too. We've been talking about it. Let's see.
And Ben, I know you're listening, so you got to put some refrigeration awards in the HVAC awards.
Oh man, I don't know how many categories they had, but yeah, I would love to see some refrigeration stuff or something of that nature. You were there last time, right? Oh yeah, I met you at the booth at Sporland.
Yeah, I've been Chris's date for the past 2 years at the Tactical Awards. I'm always his plus one.
Yeah, I didn't get to
Actually,
make it to the Vegas one because of my flight, but I made it to last year's or this year's.
yeah, I that year of Vegas, I got stuck in Vegas for 3 days. We were gonna go to the podcast pavilion and actually do a podcast from there, and I was like, no, it's gonna get storm in Dallas. I'm gonna get screwed. I'm gonna leave early. So I got to the airport early, trying to get an earlier flight. I got an earlier flight, and I'm waiting, and all of a sudden, done. She got canceled. I was like, it delayed, and then finally canceled. And I was like, dude, now I gotta find a hotel. And like, what do I do? Like, how long am I gonna stay there? Am I gonna keep going back and forth? So I decided to. I didn't know that Vegas hotels, and now that I think about this in hindsight, it's kind of creepy. But they charge these rooms in the for there's like a gym downstairs, and they charge these rooms per the hour. And I didn't think about it at first, and then I think I might have just made the dots right now, but it's fine. I stayed there for about 9 hours because I was like, my flight's at 4 o'clock in the morning. I really don't want to get a hotel and have to come back in Uber, so I'll just stay in this room. So I did that, and then woke up the next morning waiting for it, and delayed, cancel. So I think I was stuck in Vegas, like in between the hotel. I felt like Tom Hanks. I was just there, just hanging out for like the next 3 days.
I didn't even know they did that. I think I heard you talking about that on the Misfits podcast.
I have some of the most interesting conversations with people all the time. And my travel, they stopped me, and I had a relay. I came back from Houston, and I was like, I need to remember to order this relay. So I put the relay in my computer bag, so I remembered to do it. I did not remember to do it, so I got through security, and they always say you have a lot of stuff going on. So I have like 2 computers and a whole bunch of wires and shit. So it kind of looks kind of sketchy as it is. The only reason why I don't get tackled is probably because I have TSA pre-check. But yeah, so I'm going through, and they're like, what is this? And I'm like, shit. Like, it's this double pull, double throw relay. Well, why do you have it in there? And the only thing I can think of, I was like, all right, go with the answer that your wife would say. Because I'm a fucking idiot. I don't know. What do you want me to say?
So you travel a lot for the training, right?
Yeah. So like I said,
You go back and forth.
Yeah, well, besides having the 4 training centers, like I said to you before, I make curriculum for, let's just say XYZ supermarket comes out with a badass piece of equipment, right? But they didn't give any information about it. So I'll take all the drawings, I'll take all the PNID diagrams, basically all the piping and stuff. I church it up, I throw it up on, I put pressures and temperatures of what to be expected via the engineering. So they have something to look at, right? So they don't have to do the footwork. And like I said to you before, well, I'll take some of the program and break it down with some of the electrical schematics so they can actually see what that part of the program is actually doing to that. And I'll make specialized programming or specialized training for that piece of equipment. So I'm actually going to be I'm flying into Jacksonville and then driving down, I think Tuesday, down to Fort Myers, which I think is a 4.5, 5 hour ride, and then going to be there teaching for 2 days, and then getting back on the plane Thursday night and heading home. So like I do stuff like that too. Like where, I'll put on, trainings for, other people that, need help with something or whatever, if they want me there for a little bit of support. And my time's getting limited though. That's the only thing. I feel like I'm always getting pulled in 60,000 directions.
Yeah, I can tell. I mean, you have a lot on your plate. You do a lot of you do the training, you do your podcast, and it's good stuff though. Yeah, like you said, if anybody needs to, because you train for cool size specifically, so
Mhm.
if anything, they can check out the podcast because you'll post or talk about that stuff there, and that's where I heard you talk about the CO2 and that kind of stuff. So it's interesting.
Yeah, and dude, it's coming for light commercial. Like
Yeah,
they
because I was just looking at my questions. I had a guy ask me, is it going to trickle down to like reach-in coolers, all this other kind of equipment, and
reaching
here's
coolers. They're already starting to do it for. They have a small transcritical booster system, but it looks like it would be like a housing for like a 5 horsepower bone unit. You know how big that's going to be, right? As far as the dimensions. And they actually have the flash tank. They have the two freaking, the two compressors. They have the subcritical compressor. They have the transcritical compressor. So it's basically a little system, but it's all controlled with PLCs and stuff. It's coming. The only thing is it's expensive, but I mean, it has the supply chain stuff kind of, settles out or whatever. I mean,
yeah,
you're gonna start seeing an HVAC, man. Like there's a couple units. They have HVAC CO2 transcritical systems. One of the reasons why, I mean, they make awesome chillers. Chillers, they're freaking amazing. This one guy we had him on. His name's Damon Reed. He works for Pro Refrigeration, and he has this chiller that basically he does it for a lot of dairy, people that use a lot of chilled water. But then what they also do is, because CO2 is such a good refrigerant, it also heats very well. So they'll
yeah,
run the pressures a little bit higher, which will run the compressors, a little bit higher pressure, but higher pressure for CO2. Like if you're talking like a 2-to-1 and a 3-to-1 compression ratio for both those compressors, the transcritical and the subcritical compressor. So like raising the pressure up a little bit isn't really going to kill the thing. But he basically is heating almost all the water that they need for their process heating. So all their cleaning water and shit like that, he's basically refrigerating the chiller water that he needs, and then using this other side for a condenser, but then using that heat to basically reheat their water, so that the whole unit's basically a wash as far as how much energy it's consuming.
yeah, it's incredible. Um, yeah, like the whole CO2, like what blew me away was I guess the stuff before that. Like I just saw a ice machine that had 410A in it, which I had never seen before. And then package units, the trains are using microchannels in the evaporator. So just stuff is constantly changing, and I guess propane and CO2 are the next wave, I guess.
Yeah, and propane, butane, you're going to see a lot of the A2Ls, the 454s, the R32s, and propane is actually considered an A3 refrigerant. That's the I think that might be the highest flammability. I'm not sure.
Do you deal with a lot of propane, or I mean R290 as far as like training or anything like that?
Well, yeah, we actually, with all those self-contains I was showing you before the show. I think there's 5 of
Oh
them there.
yeah.
I think 2 or 3 of them are all propane. So I'm going to make that, we're working that into the light commercial curriculum. So like I was just saying before, so we have, the construction for commercial industrials, the supermarket, cold storage. We have service for construction, or I'm sorry, for commercial and industrial, and then we're doing the light commercial stuff. So our light commercial curriculum that we're putting together, basically going to go from the start of putting your gauges on to working on ice machines, self-contains, rooftop units. I added some VRF in there. I added a little teeny tiny chillers because I know most of the light commercial space, a lot of places do bars, right? So they have to make sure those lines are cold, otherwise your beer gets all frothy, and no one really digs that. So I had to make sure like whatever they're going to be working on. And like I said to you before, I push putting the VRF in the commercial. Someone said to me, they're like, I don't want to do it. And I was like, dude, it's coming. Like they're trying to do lack of refrigerant charge. Here's a really, really good way to do it. It's basically a critically charged system. I was like, I really think we should put it in the curriculum. And we did. And I'm glad we did. But yeah, that'll be one we're going to have, I think I have an area that's just going to be VRF and split systems. It's like I think 30 by 7 is the space I picked out for that. So I was showing you all the pictures of down there in Houston before the show.
Yeah, that's cool stuff. And that's cool that you do the trainings. You do the whole curriculum. You do a lot of it yourself, right?
Yeah, we have a development team, so a lot of times they'll when I make programs, like I call it shit on screen doors. So I'm just taking whatever I can think of that it would be good, and I just throw it up on the side of making these PowerPoint just things together just with ideas, and then I'll get it to a point, and I'm like, all right, now I got to fill it up with the actual content because I know what I was wanting to do, and then I got to have someone else look over it because sometimes like I know how I teach it, like a lot of things I'll teach. A little bit of safety, the history, and then we'll get into, starting with just learning the piping first. Because, if you know where the piping is, it's a lot easier, especially in these racks, right? If you look at a rack that the CO2 LMP makes an awesome rack, but there's just so many pipes everywhere. So if you tried to walk up on that and like, fuck, lost it. Nope. Shit, lost it again. So what I do is I break it down and I start with a P&ID diagram so we can actually go through the piping and talk about what it's doing. I bypass all the bells and whistles at first. So the oil separation system, the heat reclaim system, I just go through the basic thing. And then we go over to the rack and then we see how it's all piped. And then, like our CO2 class, what we're going to end up doing is basically the rack's going to start, it's going to be flat when you get there. All the guys have to go out there. We're going to talk about pulling a vacuum. We'll pull a vacuum on it. Then after we do that, let's go read some more. Oh, now it says we have to, once it's down to a good vacuum, we have to charge it with 100 pounds, 100 PSI worth of CO2. Because if I try to add liquid before it hits 68 pounds, that liquid that you're going to put in is going to turn into dry ice. So it's not going to work good. So we got to get just vapor first before we can charge it with a liquid. So charge it up to 100 PSI because then you're safely away from 68 PSI. And then, we go back in, we read, what do we do next? Oh, now we got to charge it with liquid. So we'll go out. So basically the classes that I'm trying to envelop are going to be a lot of just back and forth, because we're going to talk about it, and then let's go out and do it. Talk about it, let's go out and do it. Because, we all know that's tried and true. A lot of people say,
yeah, because everybody's a visual, hands-on learner. And I love that. So like I told you, when I went to school, we did a lot of hands-on. So if you can, teach it to them by the book and then have them go out and do it, that goes a long way.
what's going on in the chat? Anything?
You don't even want to know. Everybody's like, the chat went like the chat was out of control and there's no getting it back on the rails. Somebody, I think Val said that.
Brian's talking about Mortimer. I have a skeleton called Mortimer Grimm that I found in the trash. He's just going to sit there.
Yeah, if you guys have any questions for Brett, put them in caps. Oh, okay, I just saw the Mortimer comment.
What color Crocs does Brett have? I don't actually tan. I don't actually. Yeah, no, I do.
Yeah, like Ben said, anything new to the market is intimidating. HVAC techs don't like change. And that's why I don't like to talk to some of the guys around here. Like, I don't want to put anybody on blast, but like...
You just did.
I'm not going to name any names, I guess. We'll talk about refrigerants and changes and stuff, and they're like, oh, nothing's ever happened, or you don't need to do this, or you don't need to do that. I'm like, all right, man.
Yeah, I love, this is one of my favorite things. I've been doing that for a long time like that. Well,
yeah.
Wrong for a real long fucking time.
Yeah, and I try to be, or I try to give them the benefit of the doubt. I'm like, yeah, you got to do this, or, oh yeah, like we were talking about 407C as a retrofit and stuff. And I'm like, yeah, you just got to make that you got to do that oil change or whatever. I mean, if it's a new compressor, it'll come with POE, but you got to make sure that you have POE oil. And he looks at me like confused for a second. He's like, nah, you don't got to do that. It works fine. Or some people,
it works fine until it doesn't.
yeah. Or some people are like, well, we never get called back. And I'm like, have you been to the location since? Maybe they got somebody else. Yeah. Like, and that's the cool thing about being online. Being able to talk to you here today, or talk to some of the guys in the chat. Guys that actually give a shit about the work and how they do it, doing it the right way, and just learning as much as they can. Like, there's so many resources. That's the main thing that I tell people. They can check you out on your podcast if they needed CO2 information, stuff like that. There's Brian Orr, there's Craig on AC Service Tech, even Chris Stevens on his channel. Like, great information on those channels.
Hey, and guys, don't be afraid to ask. No one ever says yes if you don't ask, right? So if there's something that you want, Kevin and I to talk about, I'm down for anything. Like, as far as I wanted to do a VRF one. Kevin was so against it. He's like, why are we gonna do that shit? I'm like, because it's like we're dealing with it. People need to know how it works, and I'm like, it works totally opposite to what I'm used to. It's more based off mass flow. So I think that's one of the reasons why VRF has a lot of oil failures and a lot of compressor failures. Basically with a rack, rack refrigeration, we try to maintain the rack pressure at whatever saturated we're trying to maintain. That's all we do. On VRF, they have this black box, crazy, dumb technology where it's just trying to maintain a suction superheat. Where it's basically trying to run as much refrigerant through to get more mass flow, to get more cooling back to the compressor. Because a lot of the VRF stuff, they don't have expansion valves. It's just a valve that just opens up and just lets that thing flow. They're basically ramping up the speed of the compressor to bring more of that mass flow back. So it's basically like a kind of overcomplicated rack, because I mean, at least with a rack, I can tell you what's going on based off the sequence of operation and how it's supposed to be. The problem is with a lot of these VRF, it's all proprietary analog information. They don't want to actually give you, right? So sometimes it makes it hard to diagnose unless you have the thing where you plug into and it actually breaks down every single temperature sensor, right?
Yeah, I mean, we all got to get used to it. Proper training is a big deal. If you guys, I mean, we're at 2 hours and 14 minutes. I don't want to keep you too long. I don't see any other questions in the chat. A whole lot of other conversations going on. Brett Summerteeth, I don't know what's going on.
So I went down to Arkansas. And I was on the phone with Jennifer. I was like, oh my God, I know why there's so much summer teeth down here. And she's like, what the fuck are you talking about? I was like, you don't know what summer teeth are. I was like, summer teeth are, when someone has some of their teeth and some not their teeth. And so I stopped at the gas station. I drink a lot of lemonade. It's bad. I shouldn't, but whatever. So I got a little quart of lemonade, and I had it in my little fridge at the hotel, and I go to pour it out. And I usually water it down, probably one quarter of whatever the amount of fluid that I'm throwing in there, right? I couldn't, there wasn't enough water in the world to fucking de-sugar that. So now I know why there's summer teeth in Arkansas. Their sweet tea is sweet, and you think Texas tea is sweet, brother? I see you look on your face. You're like, holy shit, that's sweet, because they'll load.
I know what that is. Yeah. Yeah. So, okay. So that's why I kept seeing that comment. Right now I'm looking through and it's like summer teeth. What is summer teeth? Well, there you go. Oh, Jonathan wants to know if you were in Walmart home office.
I can't confirm or deny.
Okay. All right, guys. We're going to close this one out. What's with those Texans and their sugar? Yeah.
Dude, I don't know.
Yeah, it's a thing. Yeah, they can find you Advanced Refrigeration Podcast, Cooler Heads Podcast, Instagram, YouTube, anything else? They can email you if they need to.
Yeah.
All
They
right.
might
And if you
tell us
guys have any,
might
have any suggestions for their podcast, like you said, you're open to
Oh yeah.
talking about anything.
Yeah.
Because he's way smarter than I am, and he can break it down for you. And I always say, man, if I can do it, anybody can do it. It's just taking pride in your stuff, knowing your stuff. I have textbooks on the shelf behind me, and I'm always brushing up. That's the only way you get anywhere in this trade is just keep learning. So, yeah, if they need to reach out to you, they can email you.
Yeah.
Yeah.
Advanced Refrigeration Podcast at gmail.com. I mean,
If you guys have any, if you guys have any questions, any topics for him, like I said, check out his podcast. I appreciate everybody for stopping in. We had a hell of a chat going on, even though I couldn't see it most of the time. But
well, like all of a sudden
great
now it's
chat.
working. Like
It
it
is?
wasn't working. See, like
I just looked over 98 comments refreshed. Okay.
In Maine, we have all our teeth. I don't know if that's true. I think she's lying.
Oh, now I can highlight all the comments. Hey, right when the show ends. All right.
It's all right, dude.
All right, man. Yeah, if I have a chance, I'll get you back on here and we'll talk about some other stuff. I mean, we went over 2 hours, but there was a whole lot to talk about.
I'm so sorry, everybody.
All right, man. So I'm going to hit the outro. If you want to stick around or need to dip out, that's on you. And I'll see you guys. Let me hit the outro.
There, guys.